Mission Control, Houston, that NCC burn of 3.5 feet per second delta V will be coming up in 12 minutes 43 seconds. We're now an hour and 9 minutes away from the TI burn, terminal initiation. That's the final major burn that propels us toward LDEF and accomplishes the close-in proximity operations.
Columbia, Houston, we would like you to inhibit range rate on spec 33. We're seeing some ratty data. Item 21.
Can work. Complete.
Thanks, Wix. Columbia, Houston, we would like for you to inhibit range marks at this time.
That's complete.
Columbia, Houston, you are go to burn the onboard solution.
Thank you, Houston.
This Mission Control, Houston, with some updates to our television schedule. Next TV from Columbia should take place on orbit 48 with a downlink through the Vandenberg station at a mission elapsed time of 2 days, 23 hours and 8 minutes, or 5:43 a.m. Central, and then again through the Mila station at 2 days, 23 hours, 16 minutes mission elapsed time, or 5:51 a.m. Central. Again, these are views we think we'll be taking through the orbiter television system of both flight deck and perhaps payload bay views, and that'll be on orbit 48 upcoming shortly. This is Mission Control, Houston. This is Mission Control, Houston. The report from our flight dynamics people is the burn looked good.
The burn looked real good from down here.
Yeah, seemed to go all right.
This NCC burn had a change in velocity of about 3.5 feet per second. The duration approximately 30 seconds.
In Columbia, Houston, we'd like you to do an item 16 on spec 33, a covariance in it.
Okay.
In Columbia, Houston, in about 20 minutes, we'll be taking TV when we go across Vandenberg.
Okay, Houston, Bonnie will set something up.
Thanks, Dan. In Columbia, Houston, referencing Block 15, page 2-21, your go for auto and on range and angles, but do not select auto for range rate.
Okay, we'll leave range rate inhibited.
Thanks, Dan. In Columbia, Houston, for your information, those earlier marks did not pollute the nav state. Still looks good.
Okay.
This is Mission Control, Houston, Columbia, now crossing the equator, beginning orbit 48 about the Earth, and our next television will be coming down in about 10 minutes. The first acquisition through Vandenberg at 2 days, 23 hours and 8 minutes, or 5:43 a.m. Central, and we'll pass over to the Mila station at 2 days, 23 hours, 16 minutes, or 5:51 a.m. Central. We'll be looking through the flight deck cameras at some of the crew activities aboard Columbia as the vehicle continues to close on the long duration exposure facility. Right now we show the distance between the two spacecraft is about 110,000 feet. It's Mission Control, Houston, at 2 days, 23 hours, 7 minutes, mission elapsed time. 35 minutes now before the final large burn that will begin the latest and last phase of the LDEF rendezvous. That's the TI burn upcoming in about 35 minutes. And in the next few seconds, we expect to be taking television through the Vandenberg station, flight deck activities aboard Columbia. Right now we show the distance between Columbia and the long duration exposure facility, about 86,000 feet. And that distance of 86,000 feet equates to about 16.2 statute miles distance separating Columbia and LDEF, and now we're taking television from the flight deck of the spacecraft Columbia.
In Columbia, Houston, we have good video downlink. Appreciate the view of the flight deck activities.
As you can see, we're all in the office.
Roger that.
You going to be able to spot us coming across Houston this time? Not you yourself, but people outside.
That's negative, Columbia.
Go ahead. I'm sorry. That's negative, okay.
Yeah, Dan, there are some lighting problems. It'll be too bright.
Mission Control, Houston.
We'll have to wave then.
On this Rev 48 pass across the continental United States, Columbia will pass.
Say again, Columbia?
I said, I guess we won't have to wave then if you're not going to be able to see us.
You can always wave for the TV camera.
On this pass across the continental United States, Columbia will pass nearly above Houston, and will also pass out over the Gulf of Mexico and then over Florida. There is not a good sighting opportunity for the Houston area this morning, since in order to acquire spacecraft viewing opportunities, it's usually necessary for the observer on the ground to be near the terminator and within 15 minutes or so of local sunrise or sunset. That won't be the case here in Houston this morning, although Orlando, Florida, and the areas around do have a good sighting opportunity. In fact, an excellent one for Columbia, and perhaps just out in front of it, another dot that'll be the long duration exposure facility. That acquisition of that sighting opportunity will be at 6:53 a.m. Eastern Time. The duration of the pass about 2 minutes. The elevation 89 degrees, so almost straight up to the zenith. The Columbia will appear 15 degrees above the western horizon, and will move 86 degrees above the east-southeast horizon. And again, that acquisition of that sighting opportunity about 6:53 a.m. Eastern. And we hope it's a good pass for our friends in Florida.
In Houston, looking out my window here, we can see the lights of LA and Phoenix and assorted other cities in the southwest.
Keep us in mind as you pass by. In Columbia, Houston, even though we won't have the opportunity to see you pass over us, the folks in Florida should have a nice view of Columbia as you pass over.
Okay.
It's Mission Control, Houston. We're approaching the edge of the coverage area of the Vandenberg station. We should pass through a keyhole, and we hope to pick up again shortly over the Mila station.
Well, Houston, I would think someone was outside they could see us, because we just got lit up with sun and we're right overhead. It looks like you got a nice clear day coming for you down there.
Thanks for the good news. In Columbia, Houston, we've sent a team of observers outside to take a look and see if they can spot you as you fly overhead.
They better hurry, because I think we're on our way past.
It's Mission Control, Houston, 2 days, 23 hours, and 19 minutes mission elapsed time. We just had a report from someone here locally at Johnson Space Center that indeed Columbia was visible passing over Houston. So since that was not predicted, Perhaps the Florida pass will be even better than predicted. And that should be happening right now.
In Columbia, Houston, for your information, one of our highly trained observers spotted both LDEF and Columbia pass overhead. Also, we have your final TI pad when you're ready to copy.
Okay, we're pause a second. We'll be ready.
Roger.
Okay, we're ready.
Okay, Dan, beginning with PEG 7 targets. Delta VX, positive 000.3. Delta VY, negative 000.5. Delta VZ, negative 003.1. Maneuver attitude, roll 119er. Pitch 180. Yaw 062. Delta V tote 003.2. TGO 00:13. Vigo X positive 003.14. Vigo Y all balls. Vigo Z positive 000.62. HA 182. HP positive 175. And we're ready for the readback of the entire pad. In Columbia, we have a minute to hand over, and we'll wait for the readback of the pad until after we come out of handover.
Okay, fine. Give us a holler when you're ready.
Wilco? Columbia, Houston, we're back with you through TDRS. How do you read?
Roger, loud and clear. We just turned quit dumping through the FES, and here's the TI pad for you.
We're ready for the readback.
Okay, it's RCS burn multi-axis TV roll of 000. The weight 226,384. The TIG time 2 days, 23 hours, 42 minutes, and 32.0 seconds. The PIG 7 targets plus .3, minus .5, minus 3.1. The attitude will be 119,180,062. Delta V total is 3.2. TGO is 13 seconds. The Vigos are plus 3.14. 0 plus 0.62. We'll end up in a orbit of 182 by 175. It's no gimbal check, left ohms to RCS, no down mode, and nothing else.
Dan, that's a good readback. Columbia, Houston, we have your TI delay pad when you're ready to copy.
Okay, go ahead.
Delta VX, positive 04.2. Delta VY, negative 00.6. Delta VZ, all balls. Delta V tote, 04.2. Readback.
Okay, our delay pad is Delta VX is plus 4.2. Delta VY is minus 0.6. Delta VZ is nothing, and a total of 4.2.
That's a good readback.
It's Mission Control Houston at 2 days, 23 hours, 28 minutes mission elapsed time. In about 2 minutes, we're going to begin a replay of the flight deck television that we took through the Vandenberg and Mila stations. We'll replay that for our television users elsewhere, and that signal will be NTSC standard on NASA Select.
Columbia, Houston, be advised we're approaching the tail.
Okay.
It's Mission Control. Houston, Columbia's attitude now is such that the tail is blocking intermittently the angle between the antennas that we've selected aboard Columbia and the Tracking and Data Relay Satellite East. So we're getting some intermittent data and comm dropout, which is standard when we're in this kind of configuration. Right now the data is good, and it shows the range between Columbia and LDEF at about 71,000 feet. During the pass over Florida, that distance was a little closer to 70,000 feet due to the differences in orbital parameters for LDEF and Columbia. As the horse race continues around the world, it won't be unusual for those distance numbers to increase and decrease just a bit, but the general trend is decreasing. For a distance of 71,000 feet, that equates to about 13.5 nautical miles. And a correction, 71,000 feet equals 13.5 statute, about 11 nautical.
Columbia, Houston, you are go to burn the onboard solution.
Okay, thanks.
It's Mission Control. Houston, we're now about 2.5 minutes from the most important burn of the morning. The TI burn will set us up on a path that will lead to the final close-in proximity operations with the long-duration exposure facility. This burn will have a delta V of 3.2 feet per second. The duration of the burn, 13 seconds. The time of the burn, 2 days, 23 hours, 42 minutes, and 32 seconds. The weight of the orbiter Columbia at the time of the burn, 226,384 pounds. The resulting orbit, 182 by 175 nautical miles. This burn will use reaction control system thrusters. It's a multi-axis burn. Theoretically, at least, what this burn does is set Columbia on a path straight for the LDEF without any further action by the crew. We would pass uncomfortably close to that facility. We don't plan to make it uncomfortable. In fact, we'll then be almost immediately after the TI burn setting up for a series of 4 mid-course correction maneuvers, which will cause Columbia to pass slightly below and then out in front of LDEF in its orbit about the Earth. Columbia then will cross the velocity vector of the long duration exposure facility, pass up above it relative to the Earth, and point its payload bay down back toward the Earth with Columbia with the LDEF there in front of the bay. And it's at that point that they will be poised to capture the long duration exposure facility after a 5.5-year journey. Grapple time still hanging in there, estimated at 3 days, 2 hours, 13 minutes even. We're now 20 seconds from the TI burn. Have confirmation that the burn is underway. This is Mission Control Houston. The Flight Dynamics Officer reports the burn looked good. He says the result of the burn was good. They had a slightly high component in the Z-axis, although that's no problem. That can be trimmed out in the first mid-course correction.
Columbia, Houston, you're 4 for 4 today. We see a good burn. Like to remind you, block 20, do not select auto range rate. The data still looks noisy.
Okay, we copy.
This is Mission Control Houston at 2 days, 23 hours, 47 minutes mission elapsed time. We've just concluded a replay of the television we took from the flight deck of Columbia during the previous Vandenberg and Mila passes. We're now back with you live on NASA Select Audio. During the time that the replay was underway, the crew of Columbia performed the TI burn as scheduled on time. It was a good burn. It gave Columbia good guidance and targeting toward its final close-in rendezvous with the long-duration exposure facility. About the only nit to pick with it, the FIDO reported just a slightly high component in the z-axis, but it's nothing that can't be compensated for in the next burn, which is called MC1 for mid-course correction. So everything continuing to look very good as Columbia closes on the long-duration exposure facility.
Columbia Houston, you have a go for the RMS power-up.
Good copy, Tammy.
Mission Control Houston, next major milestone along with the targeting for Columbia's rendezvous is to get another major tool ready to go, and that's the remote manipulator arm. The power-up is about to begin. We're looking now at one of the displays here in Mission Control. This display at the PDRS console. PDRS stands for Payload Deployment and Retrieval System, and that's a way of saying for the robot arm position. What we're looking at here is a screen that shows us 3 views of the orbiter. As we move through the morning, we'll cut to this view for you and show you the arm in motion. The yellow represented in the payload bay, the yellow line is the position of the robot arm, and then up to the upper right-hand corner of the screen are some displays that indicate where the arm is and how it's operating as it moves in to snag LDEF. Of particular note for viewers, if we're able to cut to it at the right time, the 6 blocks there in the middle of that gray, that light gray area that have white and black diagonal stripes on them, those 6 blocks have to do with the end effector, and the top row of 3 diagonally striped blocks will turn to a different shade. They'll go gray as the end effector is poised to capture the long-duration exposure facility. On that top row of rectangular diagonally striped blocks, we'll see the gray take over as the arm is ready to first capture, then close, then rigidize around the grapple fixture on the LDEF. And if we're able to cut to that in real time, which is perhaps not possible since we hope to be seeing real TV pictures of LDEF at that time, but if we're able to cut to it, you would see those top 3 rectangles go gray from right to left, capture, close, and then rigidize. Also on this display, as soon as the computer system gets an indication that LDEF has been grappled, LDEF will appear up above the bay on this display.
Columbia Houston for Bonnie, we would like you to hold on the RMS activity due to the proximity of the MC1 burn.
Okay, Tammy, we copied. I'll hold.
This Mission Control Houston will defer powering up the RMS for now. We've only got about 10 more minutes remaining, 10 and a half actually, before the MC1 mid-course correction. And we'd like to have the arm fully powered up and limbered up before we do that burn or a burn. So we'll wait. We've got a substantially longer period of time between the MC1 and MC2 burns, about 30 minutes, and that allows enough time to go through the procedures correctly to power up the arm. So we'll wait till then.
Columbia Houston for Bonnie,
Go ahead.
Bonnie, we'd like you to begin the RMS activities immediately following the MC1 burn. We expect you should have about 20 minutes between MC1 and the out-of-plane null, and that should be sufficient time to complete blocks 21 and 22 if you begin right after MC1.
Okay, Tammy, I'll plan to do that.
It's Mission Control Houston, our next television. Some more TV from Columbia as the activities continue. We hope to take television on orbit 49 through Vandenberg and Mila. First acquisition would be at about 7:18 a.m. Central, 3 days, 0 hours, 43 minutes mission elapsed time.
In Columbia, Houston, we're about 2.5 minutes from LOS. We'll see you on the west side at about 7 minutes after the hour.
Okay, we'll see you there.
Columbia, Houston, for Bonnie, be advised that when you power up the RMS, you may get some encoder checks, and you are go to clear those with items 12 and 11.
Copy, Tammy.
Mission Control Houston, 2 days, 23 hours, 59 minutes mission elapsed time. The Columbia on this rev completed several milestones. The crew successfully performed the TI burn, which is the final major burn leading up to the rendezvous with LDEF. We're now at 3 days even into the flight. The arm will be unlimbered shortly after we reacquire through the western satellite in a little more than 6 minutes. During that time of loss of signal through TDRS, we will see the, well, we won't see, but the crew will see the mid-course correction, first mid-course correction burn. That'll take place in about 3 minutes, and when we come back over the hill, we'll expect a report from them. Shortly after that, we should see the arm power up, and not long after that, we'll see the arm in motion. This Mission Control Houston acquisition through the western satellite. We do see some activity beginning on the remote manipulator system.
Columbia, Houston, we're back with you through TDRS. We see a good MC1 burn.
Roger, and our preliminary solution on MC2 has a TIG of 3 days, 0 hours, 35 minutes, and 19 seconds, which is a 3-minute, 54-second slip the way we compute it.
Dan, we copy, and we'll take a look.
This Mission Control Houston, 3 days, 0 hours, 13 minutes mission elapsed time. We've come up over the hill on TDRS West and had good indications that the mid-course correction number 1 burn went well. The PDRS officer also reports that the arm is uncradled, and we see it beginning to move now up above the payload bay of Columbia. Mission Specialist Bonnie Dunbar flying the arm now. This is a real-time representation here on the ground fed by telemetry from Columbia's systems that give us a real-time indication of the position of the arm. The idea is to get the arm powered up and unlimbered and ready to go in between the burn that just took place and the burn upcoming in about 17 minutes. That next burn is the number 2 mid-course correction.
Houston, Columbia.
Go ahead, Columbia.
Okay, based on our immediate solution, we see ourselves in the in block 27 in the dotted area with a slip greater than 3 minutes and doing a burn at 3 days, 0 hours, and 34:25. Provided that the final solution holds true.
In Columbia, Houston, we see your TIG slip within a +4 minutes, and you are go to execute the block. You are not in the dotted block. How copy?
Okay, thanks for helping. We got our science control around.
Understand, Dan?
It's Mission Control Houston. We have a report that the robot arm aboard Columbia is in position and poised for capture.
Houston, we see the arm in poised for capture position. Good work, Bonnie.
Thanks, and I know you can't see the view, but I'm looking up over the overhead window at both the moon and the arm.
Super. We'll look forward to the debrief.
It's Mission Control Houston, 3 days, 0 hours, 22 minutes mission elapsed time. We're now showing again a view of one of the displays here in the control center.
Columbia, Houston, we will have Vandenberg and Mila for video opportunities in about 20 minutes.
This view we're showing on NASA Select shows the position.
Camera ready to go.
We appreciate it.
Shows the position of the robot arm aboard Columbia now. This is the poised to capture position, and it's with the arm in this geometry that Columbia will fly across and beneath the LDEF and then out in front of it and ultimately up above and over, and then we'll descend with the payload bay and the business end, the arm, pointed down toward LDEF. To the top of the screen, if you can imagine in your mind's eye, would be LDEF and beyond that the Earth. Also upcoming in about 18 or 19 minutes, we hope to acquire television through the Vandenberg station. We'll be bringing that down S-band while the KU band system is busy in the rendezvous radar mode. Right now, rendezvous radar shows us 63,000 feet behind LDEF and closing. That distance between Columbia and LDEF, about 63,000 feet or 11.93 statute miles. During the television opportunities upcoming, we have an agreement with the crew that we won't move the cameras on them. They're using all of the cameras aboard Columbia to help them in their triangulation of where the arm is, where the orbiter is relative to the long duration exposure facility. What we will be able to do, however, is cycle through the views that the crew themselves are seeing on their television monitors, and whatever is available we'll bring to you live. Mission Control Houston, 3 days, 0 hours, 26 minutes mission elapsed time. As advertised, we hope to bring you television on this upcoming pass across the United States through the Vandenberg and Mila stations. First TV we hope to have here on the ground at 7:18 a.m. Central, and that we would then pick up through Mila at 7:27 a.m. Central. Also, we have an updated time for the second mid-course correction. That TIG time, or time of ignition, 3 days, 0 hours, 35 minutes, and 46 seconds.
Columbia, Houston, be advised we're approaching the tail.
Okay, thanks. Okay, Houston, we did our final solution, and the TIG remained the same from the intermediate, 3 days, 0 hours, 35 minutes, and 46 seconds. And we got the correct science time.
Okay, Dan, we copy. Thanks.
Mission Control Houston, now 3 days, 0 hours, 36 minutes mission elapsed time. Again, we're taking another view of the display here in the control center that shows the real-time position of the robot arm. That's the poised to capture position, as if viewed from the tail of the orbiter Columbia. Right now we show the range between Columbia and the long duration exposure facility to be about 36,000 feet, We show Columbia about 31,000 feet below the altitude of LDEF and closing. The flight dynamics officer reports that the second mid-course correction burn just done also looked very good, so we're well on our way. We expect 2 more mid-course corrections.
In Columbia, Houston, MC2 was another fine-looking burn.
Thank you, Houston.
It's Mission Control Houston. Our next TV, a reminder, will come to us through the Vandenberg and Mila stations beginning at 7:18 a.m. Central Standard Time on orbit 49. We hope to see a variety of views from the flight deck and perhaps payload bay cameras of Columbia. Also a reminder, because of the television configuration that we're in for this flight, we will have to switch our satellite to White Sands to pick up this television and bring it to you. Those persons viewing
In Columbia, Houston, just a heads up, we expect you'll be about 3 foot per second hot at the 2,000 foot braking gate.
Roger.
It's Mission Control Houston, just a reminder, because of the TV config we're in,
Columbia, Houston, we'd like a repress on the left ohms.
Roger.
commentary will be available during the TV pass on the mission audio circuit, and NASA Select will carry the non-broadcast television signal. We will take the TV in and do a replay when and if appropriate. This applies to all viewers outside the Johnson Space Center area. And a correction, we're turning our satellite around to Vandenberg, not White Sands. Right now we show Columbia 27,000 feet behind LDEF, about 22,000 feet below. All going well. The call just went up from the Capcom Tammy Jernigan that we expect them to be about 3 foot per second hot when they reach the 2,000 foot mark. That's no problem. That's something that can be taken out. That's a rate that can be taken out in the subsequent mid-course corrections. Mission Control Houston, we've acquired through Vandenberg, and we're now taking television from the flight deck of Columbia. We're looking aft.
Columbia, Houston, we have good video downlink at this time. Enjoying watching the flight deck activities.
Okay, good.
In Columbia, Houston, we see a good MC3 burn.
Roger.
It's Mission Control Houston as we continue to take some views from various cameras aboard Columbia. They've just performed the MC3 burn, and that looked good. So the third of 4 mid-course correction burns has been completed. It's Mission Control Houston, this view live from the Bravo camera aboard Columbia. Correction, this is camera Delta, and we're looking at the robot arm. Now we're looking at the end effector camera. This is the camera through which we'll probably get our first glimpse of LDEF once we're close in later this morning. We believe this view we're taking through the camera on the end effector of the arm is showing us the lunar disk, the large bright object, and next to that, down to the right of it, LDEF. Mission Control Houston, this is the forward bay camera, the alpha camera, and the crew just zoomed in on this object. We believe, as Flight Director Al Pennington said, that's the object in question, the LDEF. And now we're taking a look through the Delta camera in the payload bay of Columbia, and we're going to go back inside shortly. And here we are again on the flight deck. There's Dan Brandenstein in the commander's seat. We're looking aft, David Lowe behind him. And Marcia Ivins and Bonnie Dunbar at the aft flight deck looking out over the overhead windows. Presumably at LDEF. Currently 10,000 feet away from the long duration exposure facility, about 5,300 feet below. And we've now transitioned from the Vandenberg ground station to the Mila ground station. Brief dropout there. Columbia now a little less than 2 miles away from the long duration exposure facility. This view coming to us from the Bravo camera in the payload bay of Columbia. This is LDEF centered up in the viewfinder of that camera. And now we're looking forward from the C camera toward the aft flight deck windows of Columbia. Now looking through the D camera, the Delta camera. And a reminder again, by pre-flight agreement with the crew, they're using these cameras to help themselves triangulate on LDEF and see where they are in relationship to that facility. And so we've agreed not to move the cameras around. All we're doing is just cycling through the views that the crews have selected. What we're seeing, or just saw on NASA Select, was a camera that we went to, and apparently the crew didn't have that one powered up. So we're taking these shots as they come to us and passing them along as best we can. This again is the long duration exposure facility. As best we can see it now, we're about 7,400 feet behind, about 2,200 feet below. We're back again now on the flight deck, looking aft from just above the commander's position. We have another burn upcoming. Correction, the burn just took place, the MC4 burn. A good burn is the report from the flight dynamics officer.
Columbia, Houston, we see a good MC4. You're 8 for 8.
Roger, roger.
And this is another view from the end effector camera. Again, this is the camera that will give us probably the best and most closest view of the LDEF once we get close in and are poised to grapple. We currently show Columbia 5,700 feet, and behind LDEF about 5,700 feet below, and closing at a rate of about 12.6 feet per second. So again, that's about 5,600 feet behind, about 5,500 feet below, closing at about 12.5 feet per second. We've now moved over to the A camera, and again, this is LDEF as best we can focus it in at this distance. We're now about exactly 1 mile from LDEF. We're at 5,233 feet. It's Mission Control, Houston, everything going well as Columbia closes in on the long duration exposure facility. The crew now establishing inertial rates with that facility, and we are just about in the point where manual trajectory control takes over.
Houston, Columbia.
Go ahead, Columbia.
We're on the R-bar. Keel is showing 270 degrees.
We copy, Bonnie. Looking good.
Mission Control, Houston, Columbia has just passed the R-bar. That's the longitudinal axis that passes through LDEF and down through the center of the Earth. Now they're passing below and out in front of the long duration exposure facility. Their altitude will now shortly begin to rise with relation to LDEF until they will pass out in front and climb to the precisely same altitude that LDEF now has. They'll then fly out above it and on top of it, then pointing the payload bay back toward Earth with LDEF in the field of view. We're now back outside looking at LDEF through the Alpha camera as Columbia passes below. We'll be losing this signal through the Mila station shortly, and there it went. That was the end of our downlink. Mission Control Houston, we've turned our satellite around. NASA Select is now originating again from Johnson Space Center. So commentary will be on your NASA Select audio circuit. Columbia is now 2,780 feet below the long duration exposure facility, closing at about 5 feet per second. Columbia now ascending relative to LDEF. The spacecraft now 2,550 feet below the altitude of LDEF, ascending now at a rate of about 4.5 feet per second. We'll be crossing the velocity vector, or the altitude and direction of travel imaginary line that stretches out from LDEF and prescribes its orbit about the Earth. We'll be crossing that line very shortly. That's called the V-bar. Also, a programming note, we're going to replay a portion of this last Mila pass. We'll do that very shortly. That will allow our users in places other than Johnson Space Center to see it in color. Then we will go to live television again as soon as we get close to the LDEF and can pick up about 80 feet away from it with our KU band television.
Columbia, Houston, we see the flight deck camera has reached a temperature of about 44 degrees. We'd like for you to power it off now in order to let it cool down a bit, and we'll look forward to some more TV downlink per the timeline.
Roger.
This is Mission Control Houston. We're now in the terminal phase of the rendezvous and capture events of this morning. Columbia now inside the 2,000 foot mark, now about 1,770 feet below long duration exposure facility and ascending at a rate of about 3 feet per second. They're approaching the velocity vector, the V-bar, and they'll pass out in front of LDEF at a range of between 400 and 500 feet. Mission Control Houston, Columbia now 1,350 feet below the LDEF. Grapple is now less than an hour away. All going well. The propulsion systems officer reports Dan Brandenstein is essentially making propellant, although that's a little bit of an overstatement. He says that essentially the commander is being extremely efficient in his piloting skills, and all seems to be going very well. Now 1,300 feet from LDEF, from the altitude of LDEF. It's Mission Control Houston. That concludes our replay of the Mila Pass that was just done a few minutes ago as Columbia passed over this part of the world. Columbia now out over the South Atlantic Ocean, southwest of Africa, and we are within 1,000 feet of crossing the V-bar. The estimated time of crossing the V-bar out about 400 to 500 feet in front of LDEF is at 3 days, 1 hour, 24 minutes, or thereabouts. It's Mission Control Houston. We believe our next television from the Space Shuttle Columbia will be on Orbit 50, the grapple of the Long Duration Exposure Facility. We still expect that to take place at the time as advertised at a Central Standard Time of 8:48 a.m. A mission elapsed time 3 days, 2 hours, 13 minutes. Again, upcoming, our next shuttle television, the capture of the long duration exposure facility after a 5.5-year journey. During the night, we did a little bit of back of the envelope calculations, and we determined that, at least in approximate terms, at the time of the grapple, LDEF will have been going around the Earth and will have made 32,422 orbits of this planet. When you calculate the average distance traveled in one orbit, you arrive at a fairly impressive number for the distance traveled by LDEF in the years since April 1984. We calculate a little more than 740 million miles traveled. That's million nautical miles, or 854 million statute miles, and that comes real close to approximating the distance from Earth to Saturn. Columbia now 801 feet below the long duration exposure facility. We won't, of course, be able to take any television in this final phase until we get above the altitude of LDEF and have swung over and are approaching from the R bar above the satellite. At that point, our rendezvous radar will kick off about 80 feet away, and we will then be able to send television down via the KU band system. So it'll be a little bit before we get any television of the LDEF again. And when we do, it should be very close. The rates of closure have slowed considerably. Range now 760 nautical miles. The rate of closure about three-quarters of a foot per second, about 0.75 feet per second. And a correction, of course, we didn't mean to say nautical miles. Nobody can fly that fast. We meant feet. Columbia 738 feet below the LDEF and closing at a rate of about three-quarters of a foot per second. Our best estimate for Columbia's passage across the line that demarks LDEF's altitude about 4 minutes from now. That'll be the V-bar crossing, and at that point Columbia will be about 500 feet out in front of it. This is Mission Control Houston at 3 days, 1 hour, 21 minutes mission elapsed time. Columbia is still ascending relative to the altitude of LDEF. We'll pass out in front of that spacecraft and at the same altitude shortly. While all of that is happening up in space, out over the southern Atlantic Ocean, nearing the coastline of Africa. Meanwhile, here in Houston in the Mission Control Center, a handover is underway between the Orbit 1 and Orbit 2 teams. This is what we call a hot handover. The Orbit 1 team in place working the rendezvous. The Orbit 2 team will be up to speed shortly and poised to take over just after we've grappled LDEF.
And Houston, we're a little bit long, but we're going to press ahead past the V-bar and continue on up to the R-bar.
We copy Wex, and you're looking good. Also, your prop margins remain in excellent condition.
Roger.
That was pilot Jim Weatherby reporting their solutions aboard show that they'll pass a little bit further out in front of LDEF than they'd planned. No worries there. The Columbia is fuel rich at this point and will very shortly cross the V-bar. We're counting down here in Mission Control to the estimated time of capture. Right now we show 48 minutes to the grapple of the long duration exposure facility. It's Mission Control Houston. Columbia has crossed the V-bar, now above the altitude of LDEF and out in front by about 400 feet. Mission Control, Houston, 43 minutes remaining until the capture of the Long Duration Exposure Facility. Columbia now about 80 feet above the altitude of LDEF, 352 feet out in front. They continue to climb. They're ascending relative to the altitude of the Long Duration Exposure Facility and will pass around and over the top. The line that they're shooting for is called the R-bar. That's the longitudinal axis of LDEF, and the end point of that essentially is the center of the Earth. The end point of that R-bar goes straight through the longitudinal axis of LDEF out into space, an imaginary line, and also an imaginary line down into the center of the Earth. Columbia will pass up above LDEF by about 250 to 300 feet, depending on our targeting, and right now is 320 feet out in front, 90 feet above. We, about an hour or so ago, uncradled and unlimbered the robot arm. That has been set out into the poised for capture position, and so all is ready with that system when Dan Brandenstein and Jim Weatherby bring the ship up and over and then begin the slow descent toward LDEF. The arm will be poised to capture. Again, we don't expect to see any live television because the primary means of bringing that to us, the KU band, is now engaged in the rendezvous radar mode. We'll be able to take TV when the radar kicks off about 80 feet away from LDEF as they're descending down the R-bar. It's Mission Control, Houston now inside 40 minutes before LDEF returns to the arms of the shuttle Columbia. The ship now about to pass out of range of the eastern satellite of the TDRS system. We've got about 3 minutes remaining in this pass. We'll pick up again on the western side, and about midway between Hawaii and Vandenberg.
Columbia, Houston, we're about 3 minutes from LOS. Be advised that you're about to hit a limit on your interconnect counter, and you might ring the alarm. No action required. And we'll see you on the west side at 1:43.
Roger.
About 2.5 minutes remaining before loss of signal. That was our loss of signal call from Capcom Tammy Jernigan, telling them they may get a cabin alarm having to do with the amount of time that they've been interconnected between a couple of the propulsion fuel systems. It's no impact and no action required by the crew. They can just turn the alarm off. Again, as we were saying, we'll pass out of range of TDRS East to pick up again over TDRS West. And then as Columbia's ground track plays across the face of the Earth midway between Hawaii and Vandenberg, we expect to be the approximate location at which the grapple will take place. And again, that's about 38.5 minutes from now. This is Mission Control Houston, acquisition through the western satellite of the TDRS system. We're now showing 29 minutes, 23 seconds until grapple with the Long Duration Exposure Facility.
Columbia, Houston, we're back with you through TDRS West.
Loud and clear.
Columbia, Houston, be advised we're off the tail.
It's Mission Control Houston, that call from Capcom Tammy Jernigan indicates the pointing angles between the antennas we've selected and the tail of the Columbia will interfere at some points, and so we may get some intermittent comm dropouts as the geometry goes in and out of blockage. We're anticipating arriving above LDEF on the R-bar in about 1 minute. This is Mission Control Houston, Columbia now on the R-bar at a range of 230 feet above the Long Duration Exposure Facility. Arrival at the R-bar was at 3 days, 1 hour, 45 minutes, and 45 seconds. Flight Director Al Pennington's response to that news was to say on glide slope, on center line.
Columbia, Houston, we'd like for you to switch tanks on the interconnect now.
Roger.
This is Mission Control, Houston, now 20 minutes from capture of the long duration exposure facility. We crossed the R-bar, the imaginary line directly above the longitudinal axis of LDEF at 3 days, 1 hour, 45 minutes, and 45 seconds at a range of 230 feet. We're currently descending through 186 feet at a rate of about a quarter of a foot per second. This is Mission Control, Houston, Columbia, now 173 feet above LDEF, descending at about 6 inches per second. We anticipate that we will get television back of the KU band antenna and the ability to see LDEF live when Columbia gets to about 80 feet from LDEF. Right now, passing through 150 feet. This is Mission Control, Houston, Columbia, now 130 feet above the LDEF, descending slowly. The next television we will take should be a live view of the long duration exposure facility, first time seen by those of us on the ground in 5.5 years. We hope to take that television at about 10 minutes from now. This is Mission Control, Houston, Columbia, now 90 feet above the long duration exposure facility. We expect to take television as soon as the rendezvous radar mode is deselected and we can take the KU band system to command, and that should be very shortly. Mission Control, Houston, Columbia, now 85 feet away. We're standing by to take television from Columbia momentarily.
And Houston, Columbia, the radar has been configured for copy.
We copy.
This is Mission Control, Houston. For the first time in 5.5 years, we're now looking at the long duration exposure facility. This view from above as Columbia slowly descends toward the grapple fixture that you see protruding from the side of LDEF at the top of the frame. This view coming to us from the D camera, the Delta camera in the payload bay of Columbia.
Columbia, Houston, we have a tally-ho on LDEF, and it looks even better than the SMS visuals.
Roger.
It's Mission Control, Houston, temporary loss of signal. The KU band is now back with us, and we're looking at LDEF from above. This is from the B camera in Columbia's payload bay, looking down on LDEF. This view is from a camera mounted in the keel of the payload bay of Columbia, looking straight up at LDEF. Both spacecraft now passing out over the mid-Pacific Ocean. They just crossed the equator. They're on orbit 50, and we're now looking back toward the aft flight deck of Columbia from the C camera. We're back looking through the D camera, color camera, in the payload bay of Columbia. The illumination of LDEF in this view is a mixture of the light from a full moon and the floodlights from the payload bay of the orbiter. We've been able in some of these views to see the Earth passing below. The orbiter and LDEF will be a few minutes yet before they cross the terminator and into sunlight. This view from one of the aft payload bay cameras looking forward, the left-hand window on the screen, that's Bonnie Dunbar, and on the right, Dan Brandenstein. That's the position from which he's flying the orbiter. They're looking through the overhead windows from their point of reference straight down on the LDEF. That's right. It's Mission Control. Houston, we're now going on about 3 minutes from the point at which we hope to be poised to capture LDEF. Relative motion of this spacecraft in the field of view is actually induced by the orbiter's movement. Commander Dan Brandenstein is performing a yaw maneuver to get the orbiter properly aligned so that the robot arm can reach out and latch on to LDEF. This view is from the, or that view was from the end effector camera. Now we're back to the D camera in the payload bay looking down at LDEF, below LDEF, the Earth. And not too very long that will become illuminated as both spacecraft race toward the terminator and will cross over into the sunlit side of the planet shortly. Let's view a different view from the Bravo camera from the payload bay of Columbia.
Go, Capcom.
This view from Columbia, this is from the end effector camera, the wrist or the hand joint of the robot arm, and now we've switched back to one of the color cameras in the bay. Columbia is slowly descending toward LDEF. We're approaching the point at which Bonnie Dunbar will reach out with the robot arm and latch on to what we call a grapple fixture. The report here in Mission Control is that Bonnie Dunbar has begun rolling the end of the arm. We'll pause for about 20 seconds in free drift and then make the final close-in snag of a facility that we have not seen from this vantage point since April 1984. This is a spacecraft that in 32,400 some orbits of the Earth has traveled the distance equivalent to the distance between Earth and Saturn. This view gives us a point of reference about midway down the body of LDEF, right in about the center of the spacecraft is the location of the grapple fixture that Bonnie Dunbar will be aiming for. And we, of course, will see that much closer up in just a few minutes. Approaching the terminator now, we should be coming into sunlight shortly.
In Columbia, Houston, we'd like a flight deck camera, please. In Columbia, Houston, the LDEF folks would be happy to hear any observations you care to report.
Okay, we'll talk to you after we get it on the op.
Appreciate it.
This is Mission Control. Houston, Columbia, and LDEF now coming into the sunlit portion of the planet. It's Mission Control. Houston, we're still slowly closing in on LDEF. You see before you a satellite weighing a little more than 21,000 pounds. And very shortly, Bonnie Dunbar will be snaking the orbiter's robot arm out to latch on to LDEF. This is Mission Control, Houston, 3 days, 2 hours, 24 minutes mission elapsed time. We're very close to the point at which the robot arm of Columbia will reach out and grab a hold of the long duration exposure facility after 5.5 years in space. Mission Specialist Bonnie Dunbar just improved our television picture considerably. She pulled out on the Delta camera, widened the shot so we can now see the end of the robot arm and the long duration exposure facility below that, of course, planet Earth. They'll shortly cross over the coastline of Baja California. It's Mission Control Houston, this is a live view from the camera out at the end of the robot arm. We can see from this perspective that Bonnie Dunbar is gently flying the arm above the surface of the long duration exposure facility, about to get in a position above the grapple fixture, and very shortly we hope to be in a position to snare it.
Go ahead, Columbia.
Want to know if you were in a rush? I hope not.
Dan, say again, your transmission was garbled. Columbia, Houston, say again.
You aren't in a hurry, are you?
No, we've got all the time in the world.
We're dropping down to a ground station, and we'll pick up television again shortly. It's Mission Control Houston, this view coming to you through the Merritt Island Launch Area ground station, a few miles away from the launch site where Columbia departed a few days ago. Now we're back to a view from one of the payload bay cameras. We were just a few minutes ago looking down on the LDEF from the vantage point of that arm. You see snaking into the right-hand side of the screen. There's a camera mounted there. That's what Bonnie Dunbar is using to help her guide the arm in the final few feet down to the proper point on the satellite. Still a few feet to go. Columbia still descending gently toward LDEF. Both spacecraft have just crossed Baja California, Mexico. They're now out over the Caribbean after a short hop across the Gulf of Mexico. Columbia and LDEF now passing over Cuba. We see the island of Cuba passing along beneath the two spacecraft, traveling 17,500 miles an hour at an altitude of about 178 miles above planet Earth. It's Mission Control Houston, we're back now, satellite fed. We apologize for the flickering images that came to you there. We were forced, because of some blockage, some geometry of antennas and such, to drop down to one of our ground stations, and in that mode we're not able to receive the pictures as clearly as we see them here. We're now looking from the camera on the end effector, the hand of the robot arm, as it moves across the surface of LDEF, closing in on the point at which it will reach down and latch onto the grapple fixture. It's Mission Control Houston, we're getting very close now. Just above this panel, on the next panel, should be the location of the grapple fixture, and at that point the arm will be directly above the place at which it must connect to the long duration exposure facility for the phase of this procedure that will follow, a 4.5-hour survey of the surface of LDEF, a 4.5-hour photo survey to follow. Mission Control Houston, a groan just went up in this room as we had a temporary loss of signal. We're handing over between the western and eastern satellites, and we hope to resume television coverage shortly, although we must warn that the angles are such that we may not be able to get too much television. We've now acquired signal through the eastern satellite.
Columbia, Houston, we no longer have video downlink. However, we do have you on the east satellite. No reply required.
It's Mission Control Houston, the orbiter now in free drift. We're moments away from capture. It's Mission Control Houston, we're now looking at a view of the PDRS console here in Mission Control. It's from this position that we're monitoring the motion of the robot arm. We are standing by for capture shortly.
Houston, Columbia.
Go ahead, Columbia.
We have LDEF.
Congratulations on a job well done.
Mission Control, Houston. LDEF is grappled. We're seeing it live through the computer system here in Mission Control. We copied the time of capture at 3 days, 2 hours, 41 minutes mission elapsed time. The Orbit 1 team is now being released. The Orbit 2 team will very shortly take over to conduct the 4.5-hour photo survey to follow. At 3 days, 2 hours, 42 minutes, this is Mission Control, Houston.
Columbia, Houston, your flight control team and your training team would like to congratulate you once again. You've made many scientists quite happy. Their LDEF experiments are finally coming home.
Well, we'd like to extend a special note of gratitude to Sim Soup for staying home today.
We understand, and we're handing over to Orbit 2, and you'll be speaking with Steve.
Okay, Tammy and all the folks down there that helped us, we sure appreciate it. Everything went just the way a nominal sim does. Only the visuals are a little better.
Roger that. We'll look forward to the debrief.
This is Mission Control Houston, continuing to take live television from payload bay cameras of Columbia. Absence from the field of view at this time is the remote manipulator, which has rigidized and officially captured LDEF. LDEF is back home in the arms of the Space Transportation System. With the long duration exposure facility securely latched to the remote manipulator, the next step for Mission Specialist Bonnie Dunbar will be to maneuver to the photo survey start position and set up the remote manipulator system for the beginning of the automatic maneuvering sequences, which will facilitate photographic angles and the start of the 4-hour photographic survey. PDRS officer here in the flight control room reporting the arm in motion, moving LDEF and the arm to the safe position. This is Mission Control Houston. Mission elapsed time, 3 days, 2 hours, 49 minutes. Mission Specialist Bonnie Dunbar on board Columbia, continuing to drive the remote manipulator, placing LDEF in the photo survey start position. The exact time of confirmation of a firm grapple on LDEF came at 3 days, 2 hours, and 41 minutes, or roughly 9:16 a.m. Central Standard Time today. Just a point of reference on the LDEF as it is suspended by the arm over the payload bay of Columbia. The remote manipulator end effector is grappled to the port grapple fixture. Just visible on the top of the LDEF, the starboard grapple fixture, which was an alternate grappling location. And the end facing the payload bay has been the end of LDEF that has been facing towards space during its long stay in orbit. And once the photo survey is completed, the berthing position in the payload bay will place the space-looking end forward in the payload bay. Flight controller is still watching motion on the arm here through telemetry provided through the tracking and data relay satellite system. This is Mission Control Houston. PDRS officer here in the flight control room confirms the remote manipulator and LDEF in the protect position. The arrival of the arm and the LDEF in the protect position officially concludes the formal procedures for the LDEF capture and sets the stage for the beginning of the photo survey to follow immediately.
Houston, Columbia.
Go ahead, Columbia.
Yes, are you getting any video downlink?
That's affirmative. Picture's looking good down here.
Say again, Houston.
Bonnie, the video that we were getting just a moment ago was looking great. It looks like we're getting a little bit washed out by the sun now, but we've been looking at LDEF, and it looks great.
Houston, Columbia.
Columbia, Houston, we're just off the nose. The comm will be marginal here for just a few moments.
This is Mission Control Houston. We just had a temporary dropout in the television signal from Columbia. We've got about 13.
Columbia, Houston, we see you on the way to the survey attitude, and we've got good video and comm back.
Okay, Houston. And Marcia's just clicking away like you can't believe.
Roger that.
And Houston, I don't know if you could tell from the camera on the space end, but it looks like panels H3 and H12 have some loose spoils and are kind of very loose spoils curled away from the sides.
Roger that, Bonnie. We've been looking at that and concur. We'll be looking forward to more of a close-up here.
And I don't know what kind of color you're getting, but a lot of the coatings look like they may be gone. I can see green corp on base in a lot of areas.
Roger that. Thanks for the words.
Houston, Columbia.
Go ahead, Bonnie.
I asked for the RMS folks just a couple minutes prior to grapple. The alarm on the RMS panel started ringing with no messages. It's sort of similar to something we've seen in the simulator, and then it went off. Put some tape over it, but it was still fairly loud. We don't have any explanation for it. There were no messages and no lights.
Hey, Bonnie, that happened just prior to grapple. Is that correct?
We were on the R-bar.
Roger, understand, Bonnie, and understand the tone is still going off.
Funny you should ask. The tone just came back on.
In that case, I'm sorry I said it. We'll work on it and have some words for you here later.
This is Mission Control Houston. This view from the aft end of Columbia. Now again, we're looking from the Delta camera, the wide-angle color camera, as the space end, or the end of LDEF, which has been exposed to space in its gravity gradient attitude, was showing some wear and tear there. This is Mission Control Houston. The PDRS officer here in the flight control room reports that LDEF on the end of the remote manipulator is in the position number 1 for the photo survey. Auto sequence positioning is the method used in driving the arm to that first position. The first position in the photo survey is essentially a straight up and down perpendicular to the payload bay of Columbia. Again, this camera looking up at the end of LDEF, which has been exposed to space in its gravity gradient attitude for the last several years. This is Mission Control. Noticeable on live downlink television a little earlier was one of the space-looking experiment trays on the space end of LDEF, some wear and tear noted by flight controllers here on the ground. It looks as if one of those experiments showing some from over the last few years, the heavy ions in space experiment, sponsored by the Gamma and Cosmic Ray Astrophysics branch of the Naval Research Laboratory. The experiment was originally designed and flown on LDEF to help enhance the understanding of the origin of the Van Allen radiation belts, and it is hoped that it will contribute information concerning the source and interstellar propagation of ultra-heavy nuclei. This is Mission Control Houston. This forward-looking view from one of the aft bulkhead cameras in the payload bay of Columbia shows crew members inside the crew compartment of Columbia working out the aft-looking windows. On the left-hand side, Mission Specialist Bonnie Dunbar, who's driving the remote manipulator, and on the right-hand window, behind that lens, the crew paparazzi, Mission Specialist Marcia Ivins, getting on with the photo survey.
Columbia, Houston, we'll be going LOS here in about a minute. We see you in the auto mode going toward point 2, and we'll see you back on the west satellite at 3:21.
Okay, Houston, we'll see you there.
This is Mission Control. Mission Specialist Dunbar now manipulating the robot arm and the LDEF to the photo survey position number 2. That confirmed both by telemetry from the vehicle as well as live television. And we're just about to track out of range and have tracked out of range of the Tracking and Data Relay Satellite East. We expect to acquire signal again through the western satellite in just about 7 minutes. And our next television event is scheduled to be a post-change of shift press briefing with off-going Orbit 1 Rendezvous Flight Director Al Pennington. That briefing scheduled to begin at 10 o'clock a.m. on the hour, some 14 minutes from now, in Building 2 briefing room here at the Johnson Space Center. While we do expect to see some live television from Columbia when we acquire signal again through the western satellite, that will be for a short time preempted by the change of shift briefing, again, which is scheduled to begin at 10 o'clock a.m. Central Standard Time. Just before going over the hill, we were able to see the robot arm with LDEF attached at the end, maneuvering to the second of 7 LDEF photo survey positions, and had a chance to look in the aft crew cabin windows and have a look at Bonnie Dunbar driving the arm while Marcia Ivins filled the other window with a number of cameras and lenses and loaded with various film stock in order to very thoroughly and intricately detail the appearance of all the various experiment trays along the exterior of LDEF. We're due to acquire signal again in about 5.5 minutes through the Tracking and Data Relay Satellite West. We do expect to have some more television when we acquire signal. We may have a chance to look at some of that before going to the shift briefing with off-going Rendezvous Flight Director Al Pennington. This is Mission Control Houston. Our next NASA Select television event is scheduled to be a change of shift briefing with off-going Orbit 1 Rendezvous Flight Director Al Pennington. We stand a chance of seeing some additional downlink television before that shift briefing gets underway, but just about a minute prior to the hour, NASA Select will switch to the briefing room for that change of shift press conference again on the hour, 10 o'clock a.m. Central Standard Time, with off-going Orbit 1 Flight Director Al Pennington. Standing by for contact again through the Tracking and Data Relay Satellite West, due to acquire signal in about a minute and a half. crew aboard Columbia well underway with the photo survey. That survey designed to document and preserve for post-flight analysis, good imagery taken as close to the point of grapple as possible to preserve at least a photographic state of the data available before subjecting the LDEF to the loads of reentry and rigors of the Earth's atmosphere.
Columbia, Houston, with you through Teeters West, and we see you at position 2.
Houston, Columbia, affirmative. We're doing a little out the window looking with the binoculars. We won't be able to take photos until sunrise.
Okay, Bonnie, sounds good.
Houston, Columbia.
Go ahead, Bonnie.
So if you want to select camera A, the black and white, it's a little better in the low light, and I'll pan down a couple of the rows.
Roger that. We'll do that. And we've been looking at camera temps, and it looks like cameras Bravo and Charlie are headed toward the alarm, so you might monitor those.
I'll power them down.
This is Mission Control Houston. During the recent LOS period, prior to acquiring signal through the Tracking and Data Relay Satellite West, the orbiter passed into a dark period of their orbit on the dark side of the Earth.
Columbia, Houston, we've got camera A up now, and we're getting great video.
And from the crew cabin perspective, from which Marcia Ivins is conducting the photographic documentation, the lighting conditions are not optimum for photography, so they're going to stand by until they pass again into sunlight. The next time we should have optimum lighting conditions for photography is at 3 days, 4 hours, and 10 minutes, some 40 minutes from now. So in the meantime, Mission Specialist Bonnie Dunbar using one of the aft bulkhead cameras, zooming in and panning across one of the rows of experiments on LDEF. This is Mission Control Houston. We'll be interrupting the live downlink television on NASA Select very shortly for a post-shift press briefing with off-going Orbit 1 Rendezvous Flight Director Al Pennington. This is Mission Control Houston. This live downlink television we're taking from Columbia right now, focusing on what appears to be one of the space debris impact experiments. This particular experiment designed to establish the population and size distribution of meteoroids and micrometeoroids. This is Mission Control Houston at mission elapsed time 3 days, 3 hours, and 44 minutes. We continue our live coverage of shuttle mission STS-32. This view live from the payload bay cameras of Columbia. Columbia currently on the dark side of the Earth, and as such, photographic lighting conditions are not at their optimum right now, and some of the photographic survey work is at a standstill until we cross the terminator into light again here in just a few minutes. In the meantime, this forward bulkhead camera giving us a view of LDEF on the arm in survey position number 2 gives us a fairly prominent view of rows 3, 4, and 5 on LDEF. During the change of shift briefing, Mission Specialist Dunbar took the opportunity to zoom in with this camera and pan down each of rows 3, 4, and 5 and give the folks here on the ground something of detail in the video to look at. and for recording for further analysis here. As soon as we acquire the preferred photographic lighting conditions, that time scheduled to be about 3 days, 4 hours, 10 minutes, or some 25 minutes from now. The photo survey in position number 2 will continue before moving on to photo survey position number 3. There are 7 positions identified, positions number 1 and positions number 2 being identical. So roughly 6 different positions for the photo survey. And we're midway through photo survey in position number 2 at this time. All systems aboard Columbia working well. The remote manipulator healthy and working very well. Columbia now on the ascending node of orbit 51. This is Mission Control Houston. We're continuing to take live downlink television from Columbia's payload bay as the sun rises over the Earth on both LDEF and Columbia. We should be shortly moving into the proper sun angles, which will optimize photographic conditions and can continue the photographic documentation from the crew cabin, and then move on to photo survey position number 3. This is Mission Control Houston at mission elapsed time 3 days, 3 hours, and 56 minutes. This view from one of the forward bulkhead cameras in Columbia's payload bay. LDEF on the end of the remote manipulator in position number 2, partially obscured by the shadow of the orbiter as Columbia and cargo pass across the terminator from darkness to light, partially in view and well illuminated are panels 3 and 4, or rows 3 and 4 on the LDEF. Several of the experiment trays on those rows relating to the study of space environment effects on spacecraft materials, things such as structural materials, solar power components, thermal control materials, laser communication components, and such materials that could go into the design and manufacture of spacecraft of the future, being tested in some of the experiment trays on these rows. Again, waiting for optimum lighting conditions with which to recommence the photo survey. Mission Specialist Marsha Ivins in the crew cabin with a variety of camera types, lenses, film stocks, and very busy at work doing a thorough, detailed photo documentary of the long duration exposure facility, each and every tray, every nook and cranny, in order to preserve the appearance in imagery of LDEF as it was retrieved before returning LDEF to the rigors of the Earth's environment.
Columbia, Houston, we saw the Delta camera go high, and that's probably the cause of your Spec 76 comm message.
That's right. We're powering it down.
Roger that, Dan. And talking to the pointers, we still think that optimum photography lighting ought to be from about 409 to about 427 MET.
Okay. Even at this point, we're able to get some, but it looks like we're not to optimum yet.
Roger that. We were getting good video just a moment ago. We've lost that, but about half of the LDEF looked like it was pretty well lit.
Couple little things we noticed, I guess, even before we even got close, like out at 800 feet before we got to the V-bar, it looked like there was something flying in real close formation with the LDEF, and you're never really that sure, but after we had it grappled, we did see a piece, a small, probably about a 4-inch by 4-inch segment of what looked like solar panels floating floating free and away. And then a little while later, we saw another thing. It appeared to be a little piece of aluminum floating free and away. So some pretty interesting things on the space and some of the panels, and we'll get video of it to you later, that had aluminum foil over, look like they've almost exploded. I mean, it just peeled back like a sardine can. And on panel, let me figure out which one it is for sure here. On panel 3E, for one, on AO187, there are a bunch of small rectangles, squares, and it looks like between them they're kind of like filaments. And I know there's no air up here, but it looks like they're flapping in the breeze.
Roger that, Dan. Copy it all, and thanks for the update.
This is Mission Control Houston, continuing to take live downlink television. Shuttle Commander Dan Brandenstein just reporting some of the effects and some observations they had made earlier in proximity of grapple and manipulating the LDF around on the arm. Noticed that at various points in time they had seen small sections of material, one looking like solar panel material, another one looking like aluminum, floating free and away from LDF, attesting to some of the rigors LDF and its packages have been exposed to in the harsh space environment over the last several years. He made reference to a specific panel, panel 3E, on which there is a micrometeoroid shield mounted, and noted that it had appeared to have peeled up like a sardine can. That is a passive experiment, which essentially is equipped with germanium targets, which are covered with thin plastic metallized foil used to collect residue from impacting micrometeoroids. So already just minutes in the payload bay, and we're reaping the scientific benefits of LDEF's long stay in orbit.
Houston, Columbia.
Go ahead, Columbia.
I know you only have black and white down there, but looking at tray 12 Charlie, as soon as I get over there, the fiber optic bundles definitely don't look the same color they started out.
Okay, Bonnie, thanks for the update. And we've been looking at all of your video down here of rows 3 and 4, and later on 1 and 2, and really appreciate it. Looks great.
Our pleasure. In Houston, Columbia, if you have downlink now, I'll be sending you an oblique of row 11, starting with tray A.
Into that, we've got great video, and we're looking at 11 Alpha now.
In Houston, we got a lot of static on UHF, so we turn it off for a little while.
Roger that, Columbia.
Houston, Columbia, downlinking 12 Echo right now, and we can see some brown discoloration around some of the wire leads, and it looks almost like a shadowing off the boxes.
Roger, understand, Bonnie, and we're looking at the same video down here, and the payloads folks are loving it.
This is Mission Control. This particular experiment tray, the interstellar gas experiment, designed to collect and isotopically analyze interstellar gas atoms.
Columbia, Houston, we're about a minute from handover to the east, TDRS, and when we come up on the east satellite, we'll be off the nose, so the comm may be marginal here for the next few minutes.
Good copy.
This is Mission Control Houston. We've temporarily lost signal as we hand over from the tracking and data relay satellite west to the eastern satellite. This is Mission Control. We're again taking live television from Payload Bay cameras of Columbia as Mission Specialist Bonnie Dunbar uses the onboard camera system to pan down rows 11 and 12 on LDIF. Row 12 being the lower row of experiment trays. Correction, that's 11, and now on the 12F location. This particular experiment tray located on panel number 12F, that's at the very end of row 12.
Columbia, we're back with you on the east satellite. We've got good video. We think we're looking at 12 Foxtrot.
Roger, Houston.
This particular experiment, a low temperature heat pipe experiment package.
Houston, Columbia will be going to position 4 shortly.
Roger that, Bunny, and we'll be watching you.
This is Mission Control Houston. Both downlink video and telemetry here on the ground confirm that the robot arm is in motion, maneuvering LDEF to photo survey position number 4.
Houston, Columbia, we're pausing in the auto sequence for pictures.
Hey, Bonnie, copy, and we're still getting great video.
Houston, Columbia.
Go ahead, Columbia.
Okay, we're going to try and get this on the camcorder, but we got a whole cloud of little silver and gold flecks gravitating towards the orbiter payload bay from LDEF.
And Dan, we think we were seeing that on the video downlink, and we're looking at panel, I guess, 10 Delta now, and we're seeing the foil looking like it's peeled off some.
Yeah.
This is Mission Control Houston. The glistening specks floating free between the lens of this camera and the LDEF, some of the particulate matter identified, referred to by Crew Commander Dan Brandenstein. LDEF and ARM currently in the photo survey position number 4, and Marcia Ivins in the crew cabin snapping photographs as quickly as she can move, and Bonnie Dunbar surveying the racks and trays of experiments row by row.
Houston, Columbia.
Go ahead, Dan.
They're going to get a lot of good micrometeorite hit data off of 10A and Delta. Lots of little holes in those panels. Or at least that's what it looks like to us with the binoculars.
Yeah, it looks like we'll get lots of good science out of that. Appreciate the words.
You can witness it on, have you still got downlink? Bonnie's got it on, looks like camera A.
There's that. We've still got good video, and we think that we see what you're looking at there as just some holes in the foil.
It is.
I guess that's panel 10 Echo.
That's affirmative. That's 10 Echo.
This is Mission Control Houston. This experiment tray appears to be panel number 9er Foxtrot, in which experiment number A0076 is located. That's the Cascade Variable Conductance Heat Pipe.
Houston, Columbia, we're going to give you a quick sweep of row 9.
Roger that, Bonnie. We'll be watching. We're getting great video of rows 9 and 10, and we see you on the way again to position 4.
That's right. We've paused again.
Columbia, Houston for Bonnie.
Go ahead.
Roger, Bonnie, the PDRS folks were suggesting that as you come up on a pause point, if you can transition from course to vernier rates, that may help us in the loads that we're putting on the LDF and hopefully help decrease some of the foil that is coming off of the LDF.
I copy that. I was ready to transition anyway into vernier rates per the procedures.
Roger that. Understand.
This is Mission Control Houston. We're now looking at panel number 9D. 9D equipped with a Space Environments Effects on Spacecraft Materials experiment, a panel that's configured with a variety of materials such as solar power components, thermal control materials, and laser communication components, all of which are potential components of future spacecraft. This is Mission Control Houston. That package we're just panning away from is a spacecraft coatings experiment. The circles representing a variety of coatings, including second surface mirrors, black paints, white paints, in order to understand how spacecraft surfaces will respond to the harsh environments of low Earth orbit. And we've reached the end of row 9 on LDEF, completing the left to right sweep of that particular row of experiments. In the center of the frame, tray number 9A, configured with a thermal control surfaces experiment. As is evident by the reflection in some of the experiment surfaces on LDEF, the arm is again in motion, moving along to the next photo survey position. This is Mission Control Houston. We're now looking at panel 8 Echo, configured with a experiment package to study the chemistry of micrometeoroids.
Houston, Columbia, we're going to send camera D down with some of the panels, and that's be your color one.
Roger, Dan. Looking forward to it, and we see you looking at row 8 now.
I'm sorry, say again?
Columbia, Houston.
Go ahead, Houston.
Dan, we saw you at position 4, and the lighting, I guess, was deteriorating on you there. We were wondering if we could get an update of the photo work that you've done at position 4, because we're struggling with whether or not to move on to position 5 now or wait until the next lighted pass.
We're ready to go to 5. That was our plan, to do it in the darkness here.
Roger that. We understand you're planning on
I
heading
can
on
give
to
you an
position
update
5.
if you want.
Go ahead. Columbia, Houston, we're about 2 minutes from LOS on the East Hedris. We'll pick you up on the other side at 4:58, and I guess we could get the update then. And the Incos we're seeing the temperature running a little bit high on camera A, so you might want to power it down for a while.
Okay, we'll do that, and we can give you the update when you get back with us.
This is Mission Control Houston. We're continuing to take live downlink television as we're just about to pass out of range at Hedris East, and as the sun goes down on Columbia and LDEF, 183.7 nautical miles in Earth orbit. This is Mission Control Houston. We've reacquired communications through the Tracking and Data Relay Satellite West and are now taking live television from the payload bay of Columbia. This view from the Delta camera on Columbia, looking up at the Earth end of LDEF. This is the end that has been pointed towards the Earth in its gravity gradient attitude over the last several years.
Columbia, Houston, with you through Tidris West, and we see you in position 5.
That's affirmative. We're with you.
This is Mission Control Houston. Mission elapsed time 3 days, 5 hours, and 4 minutes. We're taking live TV from Columbia, looking up from Columbia's payload bay at the Earth edge or Earth end of the long duration exposure facility. This end has been the end pointed towards the Earth as LDEF has orbited for years in its gravity gradient attitude. This is the first look we or the crew have had of the Earth end of LDEF. The triangular structure in the field of view there is the trunnion structure on either side of which is a berthing trunnion pin. Speaking of berthing, the photo survey is exactly on schedule per the timeline at this point, and barring any further delays in the photo survey, we expect to have a berthing of LDEF at approximately 3 days, 6 hours, and 55 minutes mission elapsed time, or some hour and 50 minutes away from now.
Columbia, Houston, we see camera Delta headed toward the upper band of the temperature limit, and we've got a few questions for Bonnie on the RMS master alarm that you had earlier when she's got a chance.
All right, Steve, you want us to shut camera D down now?
That's affirmative, David. If you could shut down camera Delta, that would be good.
Okay, that's in work.
Houston, Columbia.
Go ahead.
Yeah, you had a question?
Bonnie, the PDRS folks have ginned up several questions for you regarding that tone that came on, and they were wondering whether or not that correlated with any other RMS DNC activity, and whether or not the master alarm light illuminated when the tone came on.
The tone came on intermittently. It was not correlated with any action. There were no lights and no messages. It was a solid tone for a period of minutes, which stopped and then started again for just a period of minutes somewhat later. We haven't had it probably for over an hour.
Roger that. Understand. And did you ever have to silence it with the PBI, or did it just go off on its own?
Went off on its own. It didn't respond to anything with the PBI.
Roger, understand you
and
tried
just
to...
Note, it sounds, it looks a lot like an SMS funny that we used to get when the tone would come on.
Roger, understand you did try to silence it, but the tone would not respond to the PBI.
That's affirmative.
And Houston, if you'd like, we can give you camera A.
Hey, David, we're ready for camera Alpha. And Bonnie, the PDRS people are going to go back and talk about this a bit more. We may have a couple more words for you, but a suggestion, if the tone comes back on, you can reduce the volume by adjusting the rheostat. You'll need a screwdriver to do that.
Steve, that's about the first thing we tried to do, and that didn't seem to fix it.
Roger that, Bonnie. That's more good data for
Stand
us.
by.
Thanks a lot.
Stand by. Steve, just to clarify on that, we had some difficulty getting in with the tool. We're not really sure that we actually did turn it, but we haven't had any reoccurrence of it now for quite some time.
Roger that, Bonnie. Copy it all.
Houston, Columbia.
Go ahead, Columbia.
Got an electrical plan for you to do an IMAX picture in about an hour and a half, so I thought I'd let you work on it for a while. Here's the plan. The plan is I have a Y cable on A15 with the 2 photo floods. I'd like to put that Y cable right now on MO13Q, I'd like to put the IMAX cage light on A15. AFE is not on and not powered, and FEA is not on and not powered. And the reason I'd like to put the lights where I said is because that's how long the cords are. So if I can put the two floodlights and the cage light on the same bus, then that's what my plan is.
Marcia, we copy all that. We understand, and the econ folks are looking at it, and we'll be back.
Thanks. Take your time.
Columbia, Houston, for Marcia. The ecoms and the payload people have thought over your plan. They like it. They have a go to continue with that and reconfigure, and we appreciate the call.
Okay, thanks.
Columbia, Houston, for Bonnie.
Go ahead.
As you're continuing to try to isolate this tone problem that you had, we'd like to do a lamp test on the RMS Master Alarm PBI. To do that, we'd like to take the parameter select rotary switch to test and have you check whether or not the Master Alarm lights up, and 5 seconds or so in the test position ought to do it for us.
Okay, I understand. We'll do a parameter test. Stand by. And Houston, Columbia, we have a good light.
Roger that. Understand. Good light. Did you get the tone as well?
Apparently, David's been successful in turning that down. No, so I'm going to turn it back.
Roger. Copy that.
Stand by. We're going to turn it back up to see if we get the tone. Houston, Columbia.
Go ahead, Bonnie.
Okay, we turned the tone back up, and we did get the intermittent tone. And just a note, the normal tone is an intermittent type of tone. The tone we were getting was of a lower volume, and it was kind of a little continuous squeal, but it seemed to be coming from the little speaker box there under the caution warning tone volume screw, but it did not sound like the caution and warning tone.
Okay, Bonnie, we understand all that, and thanks very much. That helps us out in the troubleshooting.
You're welcome.
This is Mission Control Houston. We're taking live television from the elbow camera on the elbow joint of the robot arm aboard Columbia. The figure 7 shaped shadow on the earth end of LDEF is that of the RMS, the remote arm.
Columbia, Houston, for Bonnie.
Go ahead, Houston.
Bonnie, after looking at it down here, we feel confident that the RMS caution and warning system will still function properly, and you can rely upon the master caution or master alarm light giving you an adequate indication of any system malfunction.
Okay, thanks. And we felt that way too, just because of the difference in the tone that was coming out of the speaker there. Appreciate the words, though.
You bet.
Houston, Columbia, we're going to the next position.
Roger that, Bonnie. Understand. On the way to position 6.
Affirmative.
In Houston, Columbia, we told you turned UHF off for a little while. It's got a big squeal in it again. It's just static. It's not a squeal. I don't think there's anything wrong with the radio. There's just some interference.
Roger, understand, Dan. And we've got a request if you've got time to get to it. It looks like this East Hedras pass will be the last opportunity that we'll get to downlink the VTR playback of the grapple. And we see that LOS on the East Hedras of being around 627. So if you could get to that and set up the dump of that video, we'd appreciate it.
I'm not sure we're going to have time to rummage through all of our tapes and find the part you want, but...
Roger, understand, Dan. If you can get to it, not to interfere with any other operations, that'd be good.
Okay, when did you want it again? We'll write that down. If we happen to luck out and find it, we'll let you know.
The LOS is 627, and I guess that is going to be the last opportunity we get today. But we've got all day tomorrow to pick it up, too.
Okay, well, we'll see, but I wouldn't count on it.
Roger that, Dan. No problem.
This is Mission Control Houston. We're experiencing a temporary loss of signal as we hand over from the west satellite to the east. Mission Specialist Bonnie Dunbar aboard Columbia has manipulated LDEF into the final photo survey position, and with enough time and proper lighting constraints are very close to completing the photo survey. Should the survey be completed on time, the scheduled time for LDEF berth is mission elapsed time 3 days, 6 hours, and 55 minutes. Just about 1 hour from now at 1:30 p.m. Central Time.
Columbia Houston with you on the East Hedris. And just for information, we've got most of your family is in the room right behind us. They're watching us, and we see lots of smiling faces.
Well, great. I'm glad they could make it in.
Everybody's having a good time watching you guys work.
Houston, Columbia.
Go ahead, Columbia.
We're ready to move to position 7, and we've pretty much finished most of the photos. We've got a couple to pick up on the way around. Just want to compliment the folks at Langley and all of the investigators and those from U.S. and other countries for the fine piece of work they've put together. It ought to tell us a lot about space station and putting other things into orbit.
Roger that, Bonnie. Thanks for the words, and we're sure those folks are listening, and we're getting some beautiful video down here. We'll watch you on the way to position number 7.
This is Mission Control Houston. Position number 7 is the 7th and final position in the 7 position sequence for the photo survey. That is an identical position to position number 1. That is the start-stop position that places LDEF in a straight up and down perpendicular attitude in reference to the Columbia. Most of the photographic objectives have been accomplished at this point. There will be some additional photography as LDEF is rotated into that attitude. The next step after completing the auto sequence to position number 7 will be to prepare the orbiter television system and move LDEF to the high hover position for alignment with the payload bay, followed by the final berthing just about 1 hour away from now. Columbia and its passenger LDEF orbiting high over the Atlantic Ocean at 183.7 nautical miles on the descending node of orbit 52. Flight controllers here in Houston watching angular data and rate data as the arm drives in multiple axes at once in an automatic sequence to the perpendicular position. LDEF nearly in position already. This is Mission Control Houston, the space end, or the end of LDEF, which has been pointed towards deep space in its gravity gradient attitude as it has orbited the Earth for the last several years, showing some orbital wear and tear. In the words of Orbit 1 and Rendezvous Flight Director Al Pennington, LDEF looks like she's been rode hard and put up wet. This is Mission Control Houston, as Mission Specialist Marcia Ivins puts the finishing touches on the LDEF photo survey. Marcia Ivins' tradition in the flight control room continues here in Houston. Marcia, known for her baking feats and her feeding of her flight control room comrades, has left the present here in the control room for the Orbit 2 team in the form of a chocolate cake. This cake unveiled and presented by her astronaut comrades Jim Voss and Steve Oswald.
Columbia, Houston, we see you at position 7. And for Marcia, Jim just read your card that came with your cake to the folks in the Mocher. And we're just about to cut into your high-calorie creation here. And thanks a lot from everybody down here.
You're welcome. You deserve it.
LDEF now in photo survey position number 7, the position from which it began the photo survey, marking the end of the photo documentation as
Houston,
Columbia.
We didn't get a chance to give you an update on the photo survey a while back, but we can now. And the answer is that we got good shots of all but 4. We got shots of everything, and good shots of all but 4 with almost a dead-on 250 millimeter full frame 70 millimeter. So we got a couple that were a little oblique, and a couple we couldn't see around the window without using 100 millimeter. But everything else is showing some good photo documentation to compare with what they see when they get back.
Roger that, Dan. Appreciate the update, and we're looking forward to the photos. You guys have been doing a super job.
This is Mission Control Houston at mission elapsed time 3 days, 6 hours and 14 minutes. Columbia just about to translate across the terminator, passing from light to dark. With the LDEF photo survey complete, and LDEF and the arm in the final survey position prior to bringing it down to high hover to begin the LDEF berth operations. The opportunity to enjoy a sunset from the perspective of Earth orbit as the sun sets on Columbia and its payload.
Picture, Houston?
That's affirmative, Dan. Video looks good.
Pretty nice one, isn't it?
It's absolutely outstanding. We're really enjoying the view, and we understand it's even more magnificent for you guys. Columbia, Houston, looks like camera Delta is getting a little warm. We'd like you to power camera Delta off. Columbia, Houston.
Go ahead.
Dan, based on your update of the photo status, and after talking it over with the payload people, you have a go to continue with the berthing sequence at your discretion.
Okay, and Bonnie's on her way to high hover.
Roger that. We'll be looking.
This is Mission Control Houston. Mission Specialist Dunbar given a go to begin the preliminary berthing operations a little bit ahead of the timeline. One of the reasons for originally waiting in the timeline for good lighting conditions to start the maneuver to berthing was to allow for some additional photographs to be made during that operation, but based on the crew's comments that they've covered the entire surface area of the LDEF, they've been given a go ahead and proceed with the berthing now. So the next move will be to the high hover position, which will align LDEF with its berthing targets below in the payload bay for one good visual inspection using the CCTV cameras in the payload bay, followed by the final berthing. We're going to lose signal through the tracking and data relay satellite in about 6.5 minutes, and with that our television feed, after about an 8-minute loss of signal period, will pick up again through the western satellite, and probably for the first few minutes of that pass we'll be without KU band coverage, which means we'll have to wait a little bit longer before we get some additional television down, hopefully before the berthing operation is complete.
Columbia, Houston, we'll be losing you off the east satellite here in about a minute. We should have you for about another 3 minutes through iOS if you've got your UHF powered on. But we'll see you on the west satellite at 6:37.
Okay, we'll see you there, and we do have the UHF powered back up. The squeal was gone.
Roger that.
This is Mission Control Houston. We've lost our signal from Columbia as the vehicle passes out of range of the tracking and data relay satellite east. We do have the ability for some UHF voice communications through the Indian Ocean Station for just a few more minutes. Just prior to losing S-band telemetry through TDRS, we saw telemetry indicating that Mission Specialist Dunbar was driving the robot arm to place LDEF in the high hover position for alignment with the payload bay. Again, we've got about 8 minutes of UHF communications capability now through the Indian Ocean Station, followed by another short loss of signal before acquiring the tracking and data relay satellite west about 13 minutes from now. Again, our understanding is that the KU band communication capability will not be available due to antenna blockage for the first few minutes of the TDRS West pass, but we do expect to pick up some live downlink television again shortly thereafter. Air-to-ground traffic has been minimal, very quiet. Crew aboard Columbia quite busy wrapping up the photo survey and preparing to put LDEF in the payload bay. Columbia currently at an altitude of 180.8 nautical miles. This is Mission Control Houston. 3 days, 6 hours, and 30 minutes into the flight of Columbia, and the crew aboard Columbia, just as we lost signal through the tracking and data relay satellite just a few minutes ago, was well on their way to maneuvering LDEF on the end of the manipulator arm to the high hover position to align it with the payload bay for final berthing operations. The photo survey has been accomplished with flying colors. Commander Dan Brendenstein reporting that they had done a good job of mapping every square inch of the surface area of LDEF. And with that, we're given the go ahead and proceed slightly ahead of the timeline to prepare for the berthing operations. So when we acquire signal again through the tracking and data relay satellite east, we do expect to see LDEF either at or very near the high hover position, which is a position that is somewhat parallel to the payload bay, hovering just above it so that orbiter CCTV cameras in the payload bay can be used to visually align the payload with the payload bay. We had the opportunity to view a quite beautiful sunset on both the Earth and Columbia and her cargo just before losing the television signal. Here in the flight control room, flight controllers enjoying a Marcia Ivins flight control room tradition, despite the fact that flight controllers' oft-times colleague, Marcia Ivins, having served as a Capcom for numerous flights this year, or in 1989, found here in the control room, with the help of our Capcom Steve Oswald and Jim Voss, a chocolate cake that had been baked and left by Marcia for the flight control team. After we acquire signal through the TDRS West, we expect to be in antenna blockage for KU band communications for the first few minutes. Sometime thereafter, we do expect to pick up some signal and hope to acquire some live downlink television of the LDEF berthing operations. Again, LDEF berthing scheduled for some 20 minutes from now. will probably occur a little bit ahead of that, as the crew was given a go somewhat ahead of the schedule to go ahead and begin berthing operations, as they had completed their photo objectives a little bit ahead of the timeline.
Test.
Columbia, Houston on Tidris West.
Sound clear, Houston.
This is Mission Control Houston. We're taking communications, telemetry, and television through the tracking and data relay satellite west. At 3 days, 6 hours, and 38 minutes, we're having a look at a soon-to-be-filled empty payload bay of Columbia. Just barely entering the top of the frame is the long-duration exposure facility, soon to be Columbia's cargo, attached to the end of the remote manipulator. Visible in the aft end of the payload bay, the support structure for the previously deployed CENTCOM communications satellite.
Columbia, Houston, we see camera Alpha getting close to the alert temperature. We'd like you to power it off, please.
Hey, it's powered off.
This is Mission Control Houston. Our downlink television there was interrupted as temperature conditions on that camera were noted to be reaching their upper limit, and crew asked to power that camera off. We've been watching some camera temperature threats throughout the day, and on occasion when we saw a camera temperature reaching the upper limit, we'd power it down, give it a little while to cool down, and then power it back up and use it again. So we expect that this is going to be a temporary interruption in our TV coverage from on orbit, and are standing by to see some additional television this rev. This is Mission Control Houston. We're taking live television from the wide-angle color camera in the payload bay of Columbia. LDEF now poised in the hover position, perpendicular or parallel to the payload bay of Columbia. This is the final alignment position prior to the final berthing operations. Crew aboard Columbia now working through the berthing procedures, including the configuration of the payload retention latches, rate selection for arm operations, and then finally the slow and precise lowering of LDEF into the payload bay. This is Mission Control Houston at 3 days, 7 hours, and 12 minutes. We're looking at live downlink television from the color camera in the payload bay of Columbia as Mission Specialist Bonnie Dunbar very carefully, very slowly, and very surely drives LDEF into its transitional home, the payload bay of Columbia. This view a multiplexed or split screen shot in the bottom portion of each of the split frame screens, a very barely visible antenna or something that looks like a curb feeler protruding from the outsides of the payload bay in are the berthing whiskers. They act very much like curb feelers, providing some sort of visual reference for distance from the envelope of the payload bay to the sides of the LDEF as they translate it very slowly and carefully into the payload bay. That split screen display selected to one of the onboard monitors on the aft flight deck station, and Dunbar will be watching that very carefully as she places LDEF down in contact with the berthing whiskers.
Columbia, Houston.
Go ahead, Houston.
Roger, Dan. We know you're busy now, but we see that you have 2 good stars in the table, and if you got somebody you can break free to get us in alignment, that'll eliminate the alignment tonight later on.
Okay, we'll take care of that.
Thanks a lot. That'll save us a maneuver.
This is Mission Control as Columbia races along its 53rd orbit high above the South Pacific Ocean. Berthing operations are underway. Columbia orbiting with its tail towards the Earth and its tiled belly into the direction of travel in order to protect LDEF from any additional atomic degradation prior to return to Earth, as LDEF is lowered slowly into the payload bay. The shadow of the forward bulkhead and the KU band antenna across its face. Again, we're looking here at the space end of LDEF, or the end that has been pointed to deep space in its gravity gradient attitude, in which it has orbited the Earth for the last several years.
Columbia, Houston. The alignment looked good to us. We don't need any data. Thanks a lot.
Our pleasure.
This is Mission Control Houston. The PDRS officer here in the flight control room confirming for the flight director that LDEF is now in the low hover position. That is, it has been aligned and rolled into place for a direct deposit into the payload bay of Columbia. This is Mission Control. We have a temporary dropout as we transition from the western satellite to the east. We expect to have continued live television coverage of the berthing of LDEF in Columbia's payload bay very shortly. This is Mission Control Houston. We have temporarily lost our downlink television as the KU band antenna and its line of sight to the tracking and data relay satellite east is in blockage at this point, but we are processing S-band telemetry, which drives this nifty little display at the PDRS console, demonstrating the current precise position of the LDEF, confirmed by unexpected live downlink television as our KU band antenna comes out of blockage and finds the teeter satellite. And we're back in KU band blockage, in and out. The line of sight pointing for the KU band antenna is marginal at this point, so we expect to have continued dropouts in our downlink television. But as you can see, we have a picture now and are watching as Bonnie Dunbar slowly lowers LDEF down onto the berthing whiskers. On the left side of the split frame in the foreground and in the background, one can see vaguely two of the berthing whiskers that look something like curb feelers as they are now in contact, or appear to be in contact, with the long duration exposure facility as it's lowered. Those berthing whiskers are used to, in conjunction with this split screen provided by the onboard closed-circuit television system, to confirm accurate alignment in the payload bay before resting the trunnions on the attach points along the port and starboard longerons. This is Mission Control Houston coming into the field of view at the top. The port and starboard trunnion pins, as they're being lowered into the payload retention latches. This particular split screen view preferred by flight controllers here on the ground in order to verify accurate alignment along each longeron. LDEF now hovering just inches above its temporary home, the payload bay of Columbia. The trunnion pins visible on both sides of the split screen, just above the payload retention latch assemblies. As Columbia has crossed the terminator from light into dark, the payload bay, LDEF, and the trunnion pins being lit from below by the payload bay floodlights of Columbia. This is Mission Control Houston. PDRS officer reports data here on the ground indicating payload retention latch assemblies being readied for latch. All 4 latches in the prime for latch position. Standing by to confirm latched Perlas. This is Mission Control. LDEF trunnion pins in position for final securing to the payload bay. Payload retention latches are in proper configuration for latching. Standing by for confirmation of Perla latch. This is Mission Control. We've temporarily lost our KU band signal. We have about 4.5 minutes before losing signal through the tracking and data relay satellite east. We're still processing S-band telemetry here in the flight control room, even without the downlink television, and are monitoring telemetry as it comes in live through the tracking and data relay satellite system.
Columbia, Houston, you have a go to go ahead and latch in position hold if you desire.
Roger, Houston, thank you.
We're again processing live downlink television. Columbia in the dark at this time. This view from the Delta camera in the forward starboard location of the payload bay, just faintly visible in the field of view is the arm perched and bent high over the long duration exposure facility. In the bottom left-hand corner of the frame, you can see the right ohm spot and the vertical stabilizer. We're now 2 minutes away from losing signal through the tracking and data relay satellite.
That was camera Delta that caused the message, but we still have about 30 minutes of use before it's of concern.
Okay, thanks.
Columbia, Houston, we're about 1 minute from Tidris East LOS. We'll pick you up on the west side at 8:15.
See you then.
Mechanical Systems Officer here in the flight control room reports mechanical power to the Perlas is on. That is the final sequence prior to the latch mechanisms being thrown. And we've lost our signal through the tracking and data relay satellite east, but just seconds before going LOS, we did confirm that the keel was latched. We'll have to wait until we acquire signal again through the western satellite to confirm longeron Perla attachment, but last indication telemetry provided before losing signal was again that the keel position had latched, securing LDEF at least one of 5 attached points in the payload bay. This is Mission Control Houston. At mission elapsed time 3 days, 8 hours, and 7 minutes. NASA Select is now broadcasting live on SATCOM F2R from the Johnson Space Center in Houston. We've just lost signal through the tracking and data relay satellite east. During the last orbit, we have been watching some live downlink television from the payload bay of Columbia as mission specialist Bonnie Dunbar, operating the remote manipulator system, has lowered LDEF into the payload bay and into the payload retention latch assemblies, where it was at last glimpse before going LOS in position for latch closure. The 4 longeron latches, forward and aft, on the LDEF trunnion pins were configured for latch, and just prior to going LOS we saw the keel position latch, and we're standing by for acquisition in about 6 minutes through the Tracking and Data Relay Satellite West to confirm the 4 longeron Perla latches. This is Mission Control Houston. We're just about 1 minute away from reacquiring signal through the Tracking and Data Relay Satellite West. When we do, we hope to see confirmation that LDEF is secured in the payload bay of Columbia. Just before losing signal through the eastern satellite, we had confirmed latch at the keel attachment, and we're standing by as we saw power applied to the payload latch retention assemblies to see that those Perlas had fired and latched as well. This is Mission Control Houston. We're now processing S-band telemetry.
Columbia Houston on Teeters West. We see all 5 latches latched. Congratulations on a super photo survey and a perfect berthing. There are a lot of smiling faces down here in the control room and a lot of happy PIs across the country.
Roger, thank you. There's not a lot of happy faces, but all the faces we have up here are smiling and happy too.
I bet. Nice job, Columbia.
And Houston, we do have one question for you. I guess it's not clear exactly what attitude sequence you want now. From the message this morning, there seemed to be a couple conflicting things. One that we start the rotation at 10:15, and another that we maneuver back to the minus EOV YVV at 10:15, and that's where our confusion is right now.
Roger that, Dan. We've got a couple of changes for you on message 21B, and basically we'd like you to start there coming out of the berth at line 57 in message 21 Bravo, where it says change DAP Bravo to Bravo 9, and then we have a couple more changes.
Okay, Houston, I understand that at this point in time we should change to DAP B to Bravo 9 and maneuver to the minus XSI and initiate that maneuver at 8:25 and then start a future rotation at 10:15.
Okay, Columbia, that's all correct, except we need to change that time on line 63 from 8:15 to 8:45. And that was on page 2, of course. And then on page 3, we've got another change on line 16. That maneuver is after your crew sleep. But if you want to monitor that, you can go ahead and perform the procedures as written, and you can do that in DAP Alpha 1. If you do not wish to monitor that maneuver, then go ahead and leave the DAP in B9, and the maneuver will proceed on its own. And either of those procedures is acceptable to us.
Okay, let's see if maybe we got it this time. Okay, at 8:25, you want us to maneuver to the minus solar inertial attitude, and at 8:45, you want us to start the rotation, and then after pre-sleep, you want us to go to the minus EOV YVV, and we can do it in DAP A if we monitor it.
That's correct, Dan. Good readback.
Okay, thanks.
This is Mission Control Houston. LDEF secured firmly in the payload bay of Columbia, no longer under the control of the remote manipulator system, here under the control guidance of Mission Specialist Bonnie Dunbar. This view from the end effector camera looking directly down at the grapple fixture, a view which would have been seen had we had live downlink television as Dunbar went into grapple. Well, it appears that the shoe fits and LDEF will wear it home. The next step is to drive the RMS back into its home position.
Columbia Houston with a couple of flight notes.
Go ahead, Houston.
Roger, we have a congratulatory note for you from the LDEF folks. It reads, congratulations and thanks from the LDEF folks for an outstanding job. You have been a dedicated and devoted part of the LDEF team. We will thank you in a more substantial way when we all meet at KSC to inspect the LDEF. Signed, Bill Kennard for the LDEF team.
Oh, great, and we'd like to thank him for all his support in getting us up to speed on all the very important science and the interesting experiments that are included on LDEF. And I think they're going to have more than a handful of data to work with when we get back.
Roger that. They'll have plenty to keep them busy. And Dan, you should have two messages in the tags tray. One is a traj, and the other is the message that we just read up to you.
Okay, we only have one so far. We do have the traj one.
Roger that, Dan.
Excuse me, yeah, we got both of those.
Columbia Houston, to clarify this maneuver at 8:25, we'd like you to do that in DAP A1 and then go to B9 for the maneuver at 8:45.
Okay, that's what we're planning to do. Thanks.
This is Mission Control Houston. To correct some previous commentary, the next step is not directly to return the RMS back to its home position, but on the way there is an indicator check on one of the experiment initiation system, and that's what we're looking at right here. This is EIS indicators, EIS standing for Experiment Initiation System, on the side of LDEF near the grapple fixture, opposite the grapple fixture that was used to connect the arm to LDEF. These indicators, some 5 years ago, would have indicated experiments initiated or an on configuration. Some 5 years later, we have not expected to see anything on at this point. But just to confirm the indication on the EIS, this quick check using the end effector camera was scheduled before driving the remote manipulator back to its home position.
Houston, Columbia.
Go ahead, Columbia.
We're at the EIS checkout, and we show 6 flight indicators.
Roger that, Bonnie. We copy 6 white indicators.
This is Mission Control Houston. The white indicators mean that somewhere between the time that they were powered on 5 years ago, they have cycled off. This is not a surprise. While most of the experiment packages on LDEF are passive and do not require mechanical or electrical support, there are a number of packages on there for the planned lifetime of the LDEF flight did require mechanical support and electronic support, and when those systems were in operation and supporting those experiments, those indicators would have indicated otherwise. Other than white. This is Mission Control Houston. Payloads community here in the flight control room has provided us with a little additional insight into the meaning of the experiment initiation system indicators. The indicators would have registered black at the time of launch, many months ago. And once the experiment initiation system initiated support to those experiments on the LDEF that required it, those indicators went white. So the white appearance of all the indicators says that all the experiment initiations that were due to have begun early in LDEF's journey round and round and round the Earth all happened on time. And all those indicators appeared white before Bonnie Dunbar began driving the end effector camera away and preparing the arm for cradling. The last time the arm is due to be used on this mission.
Columbia, Houston for Bonnie.
Go ahead.
Bonnie, we need to clarify the procedures a little bit here in your pre-cradle position. In order to set us up properly for future RMS ops in the next couple of days, we need you to take wrist roll back around 360 degrees to 0. And that way will be the wrist roll range when we come up next time will be properly set up for ops.
Okay, I understand that. Negative roll to put it back into wrist roll range 3.
That's affirmative. Thanks a lot, Bonnie.
No problem. Houston, Columbia.
Go ahead, Columbia.
Yes, in driving wrist roll in the negative direction in the course rate, we got a control error light on it. We went to MAL 13.1 echo, and it has you do a diagnostics on the joint there in block 21 by taking the mode to direct, and we think it's just a function of having getting course and driving it around, and we think the joint's okay. We'd like your thoughts on that.
Okay, Bonnie, we see the message. We're looking at it. Give us just a couple of minutes, and we'll be right back.
Okay, just for info, the blocks we worked were blocks 1, 4, 6, 11, and 19, and we stopped there because it had us do a direct drive look at it, and we think you have some insight there.
Roger that. Understand blocks 1, 4, 6, 11, and you stopped in 19, and we'll be back with words momentarily.
Roger.
Columbia, Houston for Bonnie. We'd like you to go ahead and continue in MAL 13.1 echo, go into block 21 and do the direct drive check and wrist roll and continue through the procedure.
Okay, we'll do that.
This is Mission Control Houston. That last report from Bonnie Dunbar that while driving the end effector wrist in the roll axis at course rates, they received a control error alarm and are in the process of working the malfunction procedure to determine whether or not that is a real failure or not.
Go ahead, Bonnie.
Yes, we worked block 21, went to block 30. There was no caution warning check CRT light, so we went to block 31, concluded it was a false alarm or transient, and 32 is the concluding block.
Columbia, Houston. Bonnie, we concur. We saw everything that you did. We'd like you to go ahead and press on with nominal ops.
Okay, thank you.
In the course of pursuing malfunction procedures and investigations, both flight controllers and crew aboard Columbia agreeing that the alarm that was registered on board was a false alarm, and crew given a go to continue nominal ops and cradling the arm. This is Mission Control Houston. PDRS officer confirms that the MRLs are latched, indicating that the robot arm is berthed and in its cradle.
Houston, Columbia.
Go ahead, Columbia.
Yes, on Power Town, we got the same messages we got the last time we powered down the slip messages. And also, which heater would you like me to leave on?
Bonnie, we see those same 5 PDRS slip messages. Again, no action, same phenomenon, and we'd like the alpha heaters on.
Okay, copy. Alpha heaters on. Thank you.
Columbia, Houston for Bonnie.
Go ahead.
Roger, Bonnie. We see 4 joints and an all on your PDRS slip messages. That fills up the buffer down here. We'd like you to check the fault sum and see if you got messages on all of the joints.
We got 5 joints in the all. We did not get shoulder yaw. It's very similar to what we had last time.
Roger that. Understand everything except shoulder yaw. Thank you.
Affirmative.
This is Mission Control Houston. Admission elapsed time 3 days, 8 hours, and 56 minutes. NASA Select is now broadcasting on SATCOM F2R once again. On this last orbit, we saw confirmation that LDEF had been securely latched at all 5 latch points, both port and starboard longeron attachments, as well as the keel attachment, and LDEF is back where it belongs in the arms of the Space Transportation System. Since then, Mission Specialist Bonnie Dunbar has maneuvered the manipulator arm back into its cradle, where it should remain for the remainder of the flight. There are no more requirements for robot arm operations. It has been a long, hard, and very successful flight day for both flight controllers here in Houston as well as the crew aboard Columbia, and we're just 1 hour away from putting a very tired crew to bed.
Houston, Columbia.
Go ahead, Columbia.
You had asked earlier about VTR of the grapple, and all we had on board was the end effector camera view shortly after we rendezvoused up to the grapple point. We found that, and whenever you'd like that downlink, let us know.
Hey, Bonnie, we're checking to see when we can get that. We'll be right back to you. Columbia, Houston, we're going to be in blockage here shortly on the West Tidris. There should be an opportunity for us to get that downlink via the KU sometime during the East Tidris pass, and we'll have more words for you on exactly what time that'll be.
Okay, thank you.
This is Mission Control Houston. Our next shuttle television expected to be an unscheduled but welcome VTR dump.
A minute from handover from the west to the East Tidris, and we'll be able to take that VTR playback at the start of Tidris East.
Okay, copy, and just let us know. We'll get it queued up.
Roger that.
Again, our next shuttle television's an unscheduled but welcome VTR dump of the LDEF grapple, which occurred this morning about 9:15 Central Standard Time. That video was recorded on board by the crew of Columbia. LDEF grapple occurred when shuttle antennas were out of range of the tracking and data relay satellite system. And we have, as of yet, to see that piece of video, so a new view for all of us earthbound viewers as the crew of Columbia shares the moment of grapple of the long-duration exposure facility. That upcoming momentarily when we hand over to the Eastern Satellite and acquire KU band communications.
Columbia, Houston, we're with you on East Idris, and we're ready for the downlink of the playback.
Okay, stand by.
In Columbia, Bonnie, the reason we're interested in the playback is that Murphy got us, and just during the grapple, we went LOS, so we haven't seen it yet.
I'll tell you what we're going to do. We're going to give you a little bit of coming through the V-bar, a little bit getting established on the R-bar. I don't believe you saw any of that either, and we don't have any editing facilities, but, and then we'll show you the end of the grapple, too.
That'd be great, Dan. Thank you. Columbia, Houston, for Dan, we've got a number of flight notes for you before we put you to bed, and we're wondering whether you'd like to work our way through that now or get them a little later.
Well, why don't we run you back this VTR, and then we'll grab a few flight notes, and then we'll maybe be sort of done-ish.
Roger that. We're standing by.
Well, that's, as you can see coming up on the V-bar, actually, that thing looked a lot bigger than it does in that scene there. It was kind of, you'd had to estimate the distance. I think you'd have thought you were a lot closer than you were some of the times. We did, in fact, go to low Z at 1,000 feet and managed to maintain that all the way in the grapple, and the vehicle behaved pretty well. We hit the R-bar a little bit long, but rather than stop on the, we hit the V-bar a little bit long, but rather than stop on that and drive in, it looked like we had good rates and everything going, so we just motored on up through it and kept the closure a little high as we started a round up to the R-bar, hoping to get there a little sooner that way, and it all seemed to work out reasonably well. We're jumping ahead now a little bit to get established on the R-bar.
Well, we appreciate the video. We were watching you all through that on the digitals, but it sure looks good.
I was real pleased. You know, you do all that training in the simulator and in low Z, and sometimes you can get in a little bit of trouble in low Z, so you're trying to be real cautious and wondering if the simulator really simulates the vehicle. And here, just like in the simulator, you see we get some blooming of the LDEF as we get up on the R-bar. Once again, it looked like it was about in the attitude we expected, and we did the Omicron maneuver, or the 30-degree yaw. And we just barely got established on it, and we went into darkness. We had the streamlight, you know, that big spotlight from inside up and ready to go. I wasn't exactly sure how much lighting it. We were about 250 feet on the R-bar when it got dark, and I wasn't exactly sure how much lighting we were going to get out of those payload bay lights. But and we tested that streamlight before we started the rendezvous just to make sure it was working. But we didn't have to use it. The payload bay lights and the docking light did a good job. Okay, now here we're about where we picked up, and where you were seeing some of it, is we're coming up in the end effector camera and getting a good view at it. And it was slow and easy, but once again, with not knowing exactly what kind of trouble you can get into if you start bouncing off the dead bends in low Z, I was willing to take my time and just keep the rates low, and figure we had plenty of time. And as you can see, it worked out pretty well. When I finally stopped it, we had a little bit of rate on it, and a little bit of closure. It doesn't really show up in the camera, but you can see it when Bonnie starts backing off a little bit. It had just a teeny bit of closure towards her, but once again, was well within, we felt, the capability of the arm. So rather than try and fool around anymore in low Z, we just went to free drift and let Bonnie have at it.
The picture blooms a little bit here because we're actually night, and you're watching the end effector camera with a spotlight on it. Eventually we'll get some daylight. But the picture was actually quite good, and it gets better. As Dan said, there was a little bit of closure, but he did a super job. We just kind of watched this thing crawl along, and and we knew the tray, so we knew where our landmarks were right away.
Roger that, Bonnie, and we're getting some great video down here. We appreciate your commentary and Dan's, and we're just continuing to watch the grapple phase. You guys did a beautiful job.
Okay, we'll give you a few more words. We're just going to, once we work up to this tray, we knew we were getting close. Off to the right there is Don Lynn's experiment, and that was a real good landmark for us to get to where we needed to go. I was a little concerned about not having all my cameras, but, having the real thing there made it a lot easier to figure out where we were. It was interesting trying to use the cameras at some distance because we did get a lot of blooming. I played around a lot with that. I think I got my best detail on the attitude of LDF through the binoculars. I tried using the cameras and got so much blooming I couldn't tell where the keel was. So I took out our binoculars, I think they're marine issue, and looked at it, and it was very easy to tell. This next particular tray is sort of interesting because it's reflective, and you get a look back at the end effector as it's coming up on the visual there.
Roger that. We're looking at it, and it sure is a lot better video than we get out of the SMS.
Roger that. We got to this tray, and we knew that the next one up was our grapple fixture tray.
And Bonnie, this is about the point where we left you, where we lost the video.
Okay. Well, what you'll see is Dan said there was a slight closure. We had planned to do a DTO where I was going to pause for 20 seconds and we'd look at relative rates. I guess we assumed they would be in X and Z, but instead they were in Y. So we did the grapple while I was backing up. I rolled in course and then pulled back a little bit in course, went to verniers and went into the grapple. So we didn't get the 20-second delay, but I think we got some good data.
Columbia, Houston, we have a message for you from the administrator, if you're ready.
We're ready.
Okay, it reads, to Dan, Jim, Bonnie, David, and Marcia. Your mission from the moment of liftoff has inspired the people of America and the world. Today, as you flawlessly executed the LDF retrieval, literally millions paused from their daily routines and quietly watched America's space program at its very best. You accomplished a job that only the space shuttle, with its astronauts, could accomplish, and best of all, with the help of our superb NASA flight control teams, we made an extremely complex evolution look easy. I do have one gripe, and that is that I'm not on orbit with you. I'm looking forward to seeing you when you return to Earth next week. Meanwhile, thanks for providing us Earthbound folks with such an inspiring start for the 1990s. Signed, Vice Admiral Richard Truly, Administrator.
Well, that's great, and we were certainly honored to be part of the team that pulled it off.
Now, you folks did a beautiful job.
One of the things I did notice, this was my first operation and end effector course, as you notice the dynamics when I started to back away there. You get a lot of motion. And I had to stay in course so I could rotate around. Otherwise, it would have taken too long. I think it would have had to back away too far. But this got me around, and then as soon as I was aligned, I went into verniers. And then I had to do a little bit of track and capture. It wasn't too bad. Actually, Dan makes my job very easy.
Roger that, Bonnie, and we're still getting good video.
And at this point, we were extremely happy because we had a good grapple and we were ready to continue on. At this point, it doesn't show up anywhere in the video or anything, but Wexby took over and manually flew to the protect attitude and maintained that attitude throughout the photo survey. And Marcia took more photos than I'm clear to tell you, but she'll tell you in her film report tonight. And I think that'll all go well towards documenting and helping with the data that they hope to get off of LDEF.
After that, Dan, we copy it, and we were watching Wixby. We didn't see him deviate from attitude even a little bit. You all did just a super job as a crew. And we have just a few more questions for you while your memories are fresh here on the grapple.
Okay, go ahead.
We were wondering whether or not Bonnie noticed any cross-coupling during the berthing, and whether or not that was about what she expected from her SES training prior to flight.
Yes, I did see cross-coupling. The most significant cross-coupling was I tend to drift forward in X and tend to pitch down where I had to compensate by pitching up. Draper had briefed me that I would expect this type of motion, although I thought that what I experienced was a little bit more than what I saw in the simulators. I was pretty much having to keep riding on top of both of those.
Okay, Bonnie, copy all that. And did you have any comments regarding the procedures that you had integrating Wixby's manual vernier attitude control and the RMS ops?
No, we had practiced it a lot, and we knew the key to it was to talk to each other and communicate, so he knew what I was doing and I knew what he was doing, and of course David was all part of this. David was keeping us straight on what our Z position was so that we could both use the right numbers and all our displays and so forth, and whether we're vernier course, et cetera. And so it was just a function of working together and training to do it.
How'd you copy that? Did you notice any RMS dynamics during the vernier jet firings?
During vernier jet firings, the arm was solid as a rock. It looked real good.
Roger that. That's good news. And the last question we had, a couple of questions regarding the CCTVs and whether or not the bulkhead CCTVs were critical during the berth, and whether or not you were utilizing the keel camera at all.
The B and C cameras were very critical. I could not see the V guides with the A and D, so they weren't used, and I hadn't trained with them. I'd been training just with the B and C. I was using the keel camera as a cue, but there was still some question, I think, when I left as to how it really tracked down the visuals. We took the video of some of that track for the folks back in the simulator world. I had hoped to use the elbow camera on the RMS as we got low, since that was a good cue for yaw, but it was largely unusable. I tried it a couple times. It looked like there was something hanging in front of the lens, and the picture was pretty sketchy, so I ended up not using that.
Okay, Bonnie, we got all that. Did anybody else in the crew have any other comments regarding crew coordination or vehicle performance during the photo survey and the berthing?
From the orbiter side of the house, the vehicle flies extremely well in vernier with the small pulse size that we had. I did not notice any motion induced on the orbiter by the arm when Bonnie was moving the arm. I do need to thank the Draper folks for looking at the data that Bonnie and I got over in the sail when we went over and ran the simulation. The simulators are extremely good. We found that if we kept the rates of the orbiter fairly low, that any changes in center of gravity with the payload would not build up any rates significantly, and I did not see any rates build when Bonnie was moving the arm.
Okay, thanks for the comments, Wixby. Appreciate it.
The one minor problem that we did have was with some cross-coupling. Anytime you command a yaw, you get an opposite roll, and anytime you command a roll, you get an opposite yaw, and it sometimes causes you to use a little bit more pulses than you'd like. But after a while, when we got the rates where we wanted them and kept them nice and low, then it was manageable.
Roger that. What's we got it all.
Mark can give you the daily film report.
Wait one, please,
For the
Dan.
IMAX folks, we shot some Red Sea this morning, and then we shot the LDF against the black space. We shot the LDF against the Earth limb. And then in the heat of battle, we couldn't get you any more than that, and we apologize. We shot an inside shot through the 4 windows as requested, and that's all. The rest we will get for you, stage for you later. And I figure I shot around 800 shots of just LDF with the 70 and the 35, and then, I don't know, 20 minutes or so of camcorder. I could have done more, but the other guys were using the windows.
Roger that, Bonnie. Got it all. It sounds like you're busy. Thank you.
Hi, Steve. That was Marcia with the film report. And I'll just close on the RMS. I thought it was a real nice tool. Enjoyed operating it.
Hey, Bonnie, thanks a lot.
And we're ready for
Great
the
job.
flight note. And we're ready for the flight note.
Okay, Dan. First, we'd like, sometime before you go to bed, we'd like a repress on the right ohms. We plan on sending you an orbiter state vector sometime before you go to bed, so you can expect to see that. And we've got cryo config, pre-sleep after the fuel cell purge on R1. We'd like O2 and H2, tank 1 heaters alpha and bravo, 4 switches off. And O2 and H2 tank 2 heaters alpha and bravo, all 4 switches to auto. And then we need O2 and H2 manifold valve tank 2, 2 switches closed with the talkback closed. And also from the ECOM, during pre-sleep, your LIO can change out. We'd like you to ensure that you perform the actions described on lines 20 through 24 of message 24. That's the changes to the LIO procedures.
Okay, we copied all that. Repressed to right ohms. You'll send us a state vector, cryo configuration, O2, H2 tank 1, AB heaters off, tank 2 heaters auto, manifold, tank 2 manifolds closed, and check for water around the LIO canister when we do the change out tonight. And also vacuum them.
Roger that, Dan. It's a good readback. Had one other thing for you in the way of a heads up. Tomorrow we're scheduling a press conference for just after lunch. We'll be doing the pre-conference checks prior to lunch at about 3 days, 23 hours, 30 minutes. And then the conference is scheduled to begin after lunch at 4 days, 1 hour, and 25 minutes, and we'll have more words on that for you in the morning mail.
Okay, fine, thanks.
Columbia Houston, with the last question on your secondaries, just to fill out our scorecard for the day, we wondered if you had any words on FEA sample 4.
Stand by. Houston, Columbia.
Go ahead.
Marshall, I'll get back to you later.
That'll be just fine.
This is Mission Control Houston. NASA Select now broadcasting again on SATCOM F2R after a short interruption during which the crew aboard Columbia downlinked some videotape that they've been holding in their videotape recorder on board. Contents of which included some rendezvous views, including the crossing of the V-bar, that is the point at which Columbia crossed directly in front of LDEF's path. and some views as Columbia translated down the R-bar towards its target, and as well as the final stages of end effector grapple included in that playback that we'll be providing for the satellite viewers here in just a few minutes, a message from the NASA administrator to the crew of Columbia. Right now we're planning a satellite replay of all that television in about 5 or 6 minutes at 4:15 Central Time. Here in the flight control room right now, flight controllers pulling together their end of the day notes for the flight crew, let them know how to properly configure the vehicle for sleep, and waiting to hear some more from the crew on the status of secondaries and use of film on board Columbia. Again, our next shuttle television event is a replay to those satellite viewers of NASA Select of the VTR dump, which we recently received from Columbia, depicting the LDEF grapple among some other assorted rendezvous views. Coming up here in just about 5 minutes at 4:15 p.m. Central Standard Time. Again, a replay to the satellite viewers of the videotape recorder dump recently received of the LDEF grapple sequence. Again, that event, the actual end effector snaring of the long duration exposure facility by Mission Specialist Bonnie Dunbar in the crew cabin of Columbia, flown by Crew Commander Dan Brendenstein, happened while Columbia was out of range of the communication system, and we weren't able to see that live. That replay coming up in just a few minutes. This is Mission Control. Our next shuttle television is a replay for satellite viewers in NASA Select of a VTR dump, which we received here on the ground in Houston some time ago, depicting the grapple of the long duration exposure facility earlier this morning. Again, that replay coming up momentarily at 4:15 p.m. Central Standard Time, depicting the capture of the long duration exposure facility.
Columbia, Houston, we're going to lose you in about a minute on the East Hedris. We'll see you on the west side at 9:52.
Okay, see you there.
Columbia, Houston, back with you through Hedris West.
Loud and clear, Steve.
Houston, Columbia for FEA.
Go ahead, Columbia. Columbia, Houston, we're back with you. Lost the uplink momentarily. Marcia, we're ready for your FEA update.
Well, I was doing sample 4, and there was lots of rocking and rolling going on with the MC burns. Sometime after MC4, when I went down, I heard an alarm and went down to check it, and it was a pressure message. We were right in the heat of the battle here, and so I turned the heater off and came back up to the flight deck. The thing continued to translate past the limit switch where it should have stopped into the white part that's at the end of the ampule, and I have a camcorder up the ampule. Now, according to the flight rules, we can't open it and look at it. There are no pieces. The mirror shows that there's no pieces. It's a hairline crack, like in a V shape at the end of the ampule, and we're not sure if it simply translated past the limit switch where it should have stopped or what. And I guess I can clarify part of that. I got the message before it had gotten to either of the limit switches on the far end, because I looked at the little picture on the PGSC and it had not gotten to the limit switch yet. The zone was fairly large, and it was fairly excited during the burns. It was sometime after all of the burns that we got the message. It was considerable time after the burns.
Columbia, Houston, Marcia, out of here.
Houston, Columbia.
Columbia, Houston, we just got you back. We heard Marcia, most of Marcia's comments on the downlink, but we had no uplink. Go ahead, Dan.
What part didn't you hear, Steve?
Marcia, on your report, we got everything up to the point where you turn the heaters off, and then we had some intermittent dropouts after that. Could you go ahead and repeat your report after the heaters off portion?
Okay. I was monitoring the zone during the MC burns. The last time I looked was at MC4. I monitored that one, and it was fine.
Columbia Capcom, we're going off the tail again. Marcia, we'll get back with you when we get good comm.
We just checked it about 15 minutes ago, and it appears that the ampule at the far end is cracked. Did you hear the description of the crack?
Columbia, Marcia, we're getting really ratty comm at this point. You hold on for just a couple of minutes, and we'll report back when we get a good uplink.
Okay.
Columbia, Houston, we're back with you. We show good uplink and downlink.
Okay, you're loud and clear.
Hey, Marcia, we hate to make you do this again, but we still don't have much of your report past the heaters off.
Okay. Turned the heater off after I got the message, which was a ampule pressure message. I looked at the PGSC, and it had zero pressure. I think it said zero pressure. I looked to see how far it had gone along its travels. It had not gotten to either of the limit switches on the far end yet. We were in the heat of battle of getting LDEF, and so I turned the heater power off and came back up to the flight deck. We went and checked it a little while ago, and it looks like it has translated beyond the limit switch that should have shut it off. The heater element is all the way to the white part at the far end of the ampule, and there's a hairline crack in a V shape at the end of the ampule, and it's similar to cracks we'd seen in ones that we practiced with before they got the hang of sealing them well. The flight rule we know says that you can't take that out. We don't see any debris around it. We don't see any parts that are missing, and we looked at it with the bottom mirror, and what we'd like to do is open the lid and take it out, and your call.
Okay, Bonnie, we got a good copy on all that this time. Good report, and let us go off and talk about it for a little bit, and we'll be back.
Okay, Jim, thanks a lot.
I guess I owe you one. We'll see you, Marcia.
And Houston, Columbia.
Go ahead, Columbia.
Okay, let's tell you about our LIO change-out tonight.
Go ahead.
We checked down where the hub steps are, and looks like there's a little bit of water down there tonight. We scanned as best we could without taking the canister, that container back out, and knowing where we looked and where we found water yesterday, we can see quite a bit of that area without taking it out by looking through various nooks and crannies. And there's very little water, but there is some water, and actually it's on top of HUMSEP, on top of Bravo, which is the one that had the big problem the other day. And as we saw that one where it was blubbing and spitting out big globs of water, there doesn't seem to be any water coming out of A, and the screen around B seems to be wet. And by kind of tracking what little water we can see back, it almost looks like it's coming out of HUMSEP B, even though we're not using it. Now I don't know exactly how the plumbing works, and if there's some way you can backtrack from A through there, because I know the other day when we switched from B to A and I was down there working on it, by holding your hand in front of that screen duct on or port on B, you could feel a little bit of airflow even when A was running. So I guess it's over to you, but it I'm not exactly sure what's happening. If it's possible for some water to back out of A and out of B, or if we didn't get it all out of B the other day and some has just kind of migrated out over the last day, or what the story is.
Okay, Dan, we copy all that. Let us think about it for a little bit, and we should have some words for you here in a minute or two.
Okay.
Columbia, Houston for Dan.
Go ahead.
So Dan, the ECOMs are wondering if you could give them an estimate of how much water it is that you're seeing, and also whether or not you noticed any water in that same area this morning.
Gee, David did it this morning and said he didn't notice any water there, and he took a look at it tonight again, and he'd spent some time in the villages with me yesterday, so I don't know, apparently it may have came out during the day. And how much is down there? Probably 8-10 ounces, maybe. That's kind of a swag, but maybe a little bit less.
Okay, Dan, we'll copy all that, and we'll still go off and think about it and have more words for you. And we have another question for Marcia on FEA.
Go ahead, Steve.
Marcia, the payloads people were wondering what the heater setting was, what heater power you had on FEA sample 4. And they're wondering about the power setting at the time that you got the message.
Okay, didn't hear the first part. Say it again.
So the question was what heater power you had set when you got the message, the ampule pressure message.
Okay, stand by. The last heater power setting was 41. The temperature was 231. That was at least an hour before we got the message. I had a fairly large zone, larger than I should have. We had a late start, and I ran the temperature up high until the zone was established and then brought it back down. It was running about 50. The zone still looked too large, and so I had it down to 44, and then I put it down to 41, and that's where I left it. So that's probably about the temperature it was when we got the message.
Okay, Marcia, thank you. We copied all that. Columbia, Houston for Dan.
Go ahead.
Roger, we just sent you an orbiter state vector, and we've been talking with the econ people, and they've been watching HumSat Bay, and they think that it's performing real well. Your relative humidity in the cabin has stayed well within limits, and what we're thinking is that the water that you're seeing is residual water from the problems that we had with HumSat B earlier that is somehow shaken loose during the firings today. And other than just mopping up residual water that's around there, we have no action for you on that.
Okay, well, we'll keep an eye on it each time we do a lyo change out.
Roger that. Columbia, Houston.
Go ahead.
Roger, we'd like you to leave FEA in its current configuration. We're going to go off and look at that overnight, and we'll have words on that for you in the morning. Basically, we'd like to sign off at this point. We'll talk with you in the morning. Congratulations again on a super day. You all did a fantastic job, and we'll be turning over to the planning team here, and Don will be watching you overnight. So congratulations again.
Okay, well, thanks a lot. We couldn't have done it without your help. We appreciate it. We'll see you tomorrow.
Hey, good night.
This is Mission Control Houston. Our next television event on NASA Select is a change of shift briefing with off-going Orbit 2 Flight Director Bill Reeves and LDEF Chief Scientist Bill Kynard from Langley. That event coming up at 6 o'clock p.m. Central Standard Time, about 45 minutes from now, originating from the Building 2 briefing room here at the Johnson Space Center. This is Mission Control Houston. Our next NASA Select television event is scheduled to be a change of shift briefing with off-going Orbit 1 flight director and from the Langley Research Center, LDEF Chief Scientist Bill Kynard. That briefing is scheduled for just about 30 minutes from now at 6 o'clock p.m. Central Standard Time, and will originate from the Building 2 briefing room here at the Johnson Space Center. Once again, our next television event, a post-shift press briefing with off-going flight director Bill Reeves and LDEF Chief Scientist Bill Kynard.
This is Mission Control Houston at a mission elapsed time of 3 days, 11 hours, 11 minutes. Columbia now beginning orbit 56. Planning team just settling in for an evening's work following a successful day of retrieval of the long duration exposure facility. And our next television event will be a change of shift briefing with off-going orbit 2 flight director Bill Reeves. Joining Mr. Reeves on the console in Building 2 will be the LDEF Chief Scientist, Bill Kynard. That briefing is scheduled for 6 p.m. Central Standard Time, and that is in Building 2, Room 135 here at the Johnson Space Center. This is Mission Control Houston. Loss of signal through the tracking and data relay satellite east. We'll pick up the signal through the western satellite in about 6 minutes. We're standing by for a change of shift briefing with off-going Orbit 2 Flight Director Bill Reeves and LDEF Chief Scientist Bill Kynard. That briefing is upcoming shortly. This is Mission Control Houston. The planning team settling in for their evening's work, preparing messages to be uplinked to the crew when they wake up, now about 6 hours and 10 minutes from now. A number of activities are scheduled for tomorrow, including hopefully getting some more ground IMAX targets. They also will activate and experiment the latitude-longitude locator, or L-cubed experiment. That target list for that will be hopefully uplinked to the crew in the morning mail. There's also a possibility of a pass over Hawaii for the Amos experiment, and that hopefully will show the payload bay of Columbia lit and see if the ground will be able to get any targets there of Columbia as it passes over. Also to be activated will be the fifth sample of the fluids experiment apparatus. Other messages that will be uplinked will include some words on the humidity separator, a text and graphic system in-flight maintenance procedure to see if we can get that system working. During the handover from the Orbit 2 team, it was reported by the PDRS officer that the remote manipulator system arm worked very well, save for one master alarm which failed on. That's an audio circuitry in the panel, and the crew simply turned the volume down on that alarm and continued on. There was no action required that would have endangered the use of the arm whatsoever. And of course, earlier today, the primary mission objective, retrieval of the long duration exposure facility, occurred. LDEF is now safely cradled in Columbia's payload bay, ready for the trip home, and the trip is scheduled for a week from today. The remainder of the mission will be in support of extending the capability of the orbiter, and a number of detailed supplementary objectives are planned for the remainder of the mission, as have already been accomplished, to continue to evaluate the physiological changes that the crew will see for the next several days. Columbia is currently in a 182 by 176 nautical mile orbit. And for those who like precise numbers, the center of gravity of Columbia is 21 1,000ths of a nautical mile behind LDEF. And there is no closing rate whatsoever, of course, since LDEF is in the payload bay. And with that, the JSC transmission of NASA Select will be interrupted so that Landsat can use it. That transmission will be interrupted beginning at 6:30 p.m. Central Standard Time. And we expect that broadcast on NASA Select, of NASA Select on SATCOM F2R will resume at approximately 9:30. There may be an interruption of that to bring down some TV from the payload bay of Columbia Earth views, and that could occur at the top of the hour at 7 p.m. Central Standard Time, and we will bring the satellite back for that and then hand it back over to Landsat following the downlink TV. In that event, the next transmission may be non-standard. This is Mission Control Houston. The Landsat folks have decided that they would keep the satellite here with NASA Select through the downlink and are not planning to take the satellite away until 7:30 p.m. Central Standard Time. This is Mission Control Houston at 3 days, 12 hours, 20 minutes. We're about to switch the satellite around and hopefully take some downlink television from Columbia's payload bay. And following the downlink television, we will resume coverage of NASA Select through SATCOM F2R at approximately 9:30 p.m. Central Standard Time, following use by the Landsat folks. This is Mission Control Houston. This is Mission Control Houston. We're now taking some downlink TV from the payload bay of Columbia. We're looking down as we pass over South America at some quite dramatic thunderstorm activity over that continent. It's reported by our weather officer that the cloud cover there, the tops are between 40 and 50,000 feet, where you see those dramatic lightning bursts there. This downlink television is in support of the mesoscale lightning experiment aboard Columbia. MLE has flown on several previous flights and has gotten some very good data. And this will no doubt help those folks out in their search to better understand the effects of lightning and how exactly that works. This is Mission Control Houston at a mission elapsed time of 3 days, 14 hours, 4 minutes. We're now taking payload bay views from Columbia as the ship passes over South America, hoping to see some lightning as we saw in the last pass. The lighting you see is from the moon, and that lighting has given our weather officers an added touch to looking at the clouds. Actually, we get some good dimensions on the clouds, the tops of which some of are around 50,000 feet. This is Mission Control Houston. We're now back on NASA Select through SATCOM F2R, transponder 13. Columbia just beginning orbit 58. Everything continuing to go very smoothly here on the planning shift in the control center. Messages now being reviewed for uplink to the crew when they wake up. That's scheduled now for 3 hours and 47 minutes away.
Once awake, the crew will begin a busy day of activities related to secondary payloads, fluids experiment apparatus, protein crystal growth. They will fire up the latitude-longitude locator, the L3 experiment. We're also hoping that we may get a pass over Hawaii for the Amos experiment, which will hopefully view the lighted payload bay of Columbia with LDEF in it as it passes over. The planning shift here has gone very smoothly and all is going very well. It's all very quiet at this moment as controllers review messages, again, which will be teleprinted up to the crew later this morning or this evening. One of the messages will be an in-flight maintenance procedure to troubleshoot the text and graphics system to see if we can possibly bring that back online for use during the flight. It has been used sporadically thus far, and we're hoping to get that operational for the remainder of the flight. We've had a couple of good passes over South America, saw some lightning in support of the mesoscale lightning experiment. The weather officer reported that with the moon shining on the top of the clouds, it gave an added dimension, allowing the weather officers to look at the dimensions of the clouds with the lightning in them. Reported that some of the tops of those clouds were in the range of 40 to 50,000 feet. We're currently at 3 days, 14 hours, 14 minutes into the flight of Columbia on STS-32. This is Mission Control. This is Mission Control Houston. We're about 9 minutes away from losing signal with Columbia through the tracking and data relay satellite east. We'll be waking the crew up in about 3 hours and 35 minutes from now. Our next television event will be a replay of Flight Day 4 activities. That replay is scheduled for mission elapsed time of 3 days, 15 hours, 25 minutes, or translates to 10 p.m. Central Standard Time this evening. And that replay will last for approximately 11.5 minutes. This is Mission Control Houston at 3 days, 15 hours, 10 minutes. Mission elapsed time. Our next television event will be a replay of Flight Day 4 activities, the highlight of which is the retrieval, rendezvous, grapple, retrieve, photo survey, and berthing of the long duration exposure facility. That Flight Day 4 activities replay will begin in about 15 minutes at mission elapsed time 3 days, 15 hours, 25 minutes, or 10 p.m. Central Standard Time. That replay is scheduled to run for about 11.5 minutes. This is Mission Control Houston. Our next television event, a replay of Flight Day 4 activities, is scheduled for 10 p.m. Central Standard Time. That's upcoming in about 5 minutes. That replay will last 11.5 minutes. And that will occur at a mission elapsed time of 3 days, 15 hours, 25 minutes. This is Mission Control Houston, back now in Mission Control Room following that replay of Flight Day 4 activities. That replay will be shown again at 3:30 tomorrow morning for you insomniacs around the country here. That replay again lasts for about 11.5 minutes and is scheduled for an mission elapsed time of 3 days, 20 hours, 55 minutes. Again, that will be replayed at 3:30 tomorrow morning. This is Mission Control Houston, a mission elapsed time of 3 days, 16 hours, 32 minutes. Columbia now passing over the continent of Australia on the descending node of orbit 59. Planning shift controllers continuing to review messages, which will be uplinked to the crew when they wake up, now a little less than an hour and a half. Most of the messages that will be uplinked relate to their activities for the day, including secondary payloads, messages from home, and of course a mission summary. The updates to the flight plan reflect sunrise and sunsets being 42 minutes earlier than scheduled on the published flight plan. And several of the activities have moved around a bit, and those will be reflected in the execute package when it comes out later this morning. Here in the Houston area, if the weather is clear tomorrow morning, we are hoping to get a look at Columbia as the orbiter passes over the Houston area. That pass over Houston is scheduled for 6:11 a.m. and the duration of that viewing will be for about a minute, with a maximum elevation of 66 degrees. Columbia will be appearing at 33 degrees above west-southwest, climbing to its 66 degree elevation, moving in a direction above 65 degrees to the south. This is Mission Control Houston, now 34 minutes away from waking the crew to begin their Flight Day 5 activities. Crew wake up is scheduled for 12:35 a.m. Central Standard Time, or a mission elapsed time of 3 days, 18 hours. Orbit 1 team members beginning to filter into the control center to take handover from the planning shift. Planning shift members are making final corrections and updates to the messages that will be uplinked to the crew when they wake up. This is Mission Control Houston. Columbia now passing over Africa on the ascending node of orbit 60. We're about 7.5 minutes away from losing signal with Columbia through the tracking and data relay satellite east. Once we acquire signal on the western satellite, we will be waking the crew up. And that's currently scheduled for 12:35 a.m. Central Standard Time. Orbit 1 team members are now in the process of taking handover from their planning team counterparts. That handover lasts from about 12 midnight to 1 a.m. The planning team will be handing over a very clean orbiter and crew and new payload. The long duration exposure facility, which was grappled, retrieved, and berthed in LDEF's payload in Columbia's payload bay yesterday. In our next television event is a change of shift briefing with off-going planning team flight director Bob Castle. That shift briefing is scheduled for 1:30 a.m. Central Standard Time in Building 2, Room 135 here at the Johnson Space Center. Any news media interested in taking part in that briefing should notify the JSC News Center at area code 713-483-5111.
Good morning, Columbia.
Morning, Houston.
Your music this morning is courtesy of the LDEF project, who are obviously very happy today. And our planning team would also like to extend their congratulations on an exceptionally successful day yesterday.
Well, thanks to the LDEF crew, and we enjoyed doing it and are equally happy.
And Columbia, we have several messages being both tagged up and teleprinted up this morning. You should have about 4 messages, actually 3 messages coming up in the tags, including 3 satellite photos. On the teleprinter, you should have the flight plan update and the mission summary, and the rest is on its way.
Okay, well, let us take an inventory here, and we'll see what we got.
Roger that.
This is Mission Control, Houston. The wake-up music this morning was in honor of Columbia crew's successful rendezvous and grapple with the long-duration exposure facility yesterday. And that music comes to us from the folks at the Langley Research Center.
And Columbia, Houston, you should have all the teleprinter messages on board at this time.
Okay, we'll check. Thanks.
This is Mission Control, Houston. Our next television event is a change of shift briefing with off-going planning team flight director Bob Castle. That briefing is currently scheduled for 1:30 a.m. Central Standard Time. That is scheduled for room 135, building 2 here at the Johnson Space Center. News media interested in taking part in that press conference should call the newsroom at area code 713-483-5111.
Houston, Columbia.
Go ahead, Columbia.
When it's okay with you, I'll do KU band antenna cable positioning.
And Columbia, your go for the KU band antenna cable positioning.
It worked. Houston, Columbia.
Go ahead, Columbia.
Yeah, I incorrectly started the fuel cell purge, but before it really started purging, I terminated it to get the cryo config complete, and then I'll go back and do the fuel cell purge. Sorry about that.
No problem. We copy.
This is Mission Control, Houston. Our next television event, a change of shift briefing with off-going planning team flight director Bob Castle, has been canceled. And with that, the planning team will now hand over to the Orbit 1 team to take over the activities for the crew's first portion of their wake shift.
Houston, Columbia, cryo to tank heater sensor check complete.
We copy that, Columbia. And they look good to us. Columbia, Houston, your planning shift is signing off for the morning, and you're going to be taken over by Orbit 1, and you'll be talking to Tammy. Have a good day.
Okay, thanks a lot for your help and everything, and we did get the full inventory of teleprinter messages and tags messages, so we're scurrying through those and trying to get sorted out for the rest of the day.
Okay, good luck to you.
Houston, Columbia.
Go ahead, Columbia.
Yeah, yesterday we went on a search for the second TV cable to connect in-cabin TV to either the mid-deck or the flight deck outlet. Over the night, did you folks come up with any other ideas where that might be, or did you verify with Ray Malone that, in fact, 2 of them got packed?
And stand by 1. We'll check. Columbia, Houston, we have some words for you on your 20-foot TV cable.
Okay, go ahead.
Dan, according to the Boeing folks, the cable was never packed, so we're sorry for sending you on the wild goose chase.
Okay.
This is Mission Control Houston at 3 days, 19 hours, 13 minutes mission elapsed time. Columbia is over Africa right now, as is the LDEF, snug in the payload bay of Orbiter Vehicle 102. We're looking now live from one of the cameras in the payload bay and some ground-controlled TV from Columbia. This is the Delta camera, looking in on the LDEF from the perspective of the aft flight deck. This is what the crew sees when they look out the window. The orbiter is flying about the Earth in a minus ZLV attitude, which essentially translates to payload bay to Earth, as you can see here. And below is Africa. Columbia now flying over one of the drier spots on the planet. This is the Sahara Desert in northeastern Africa. Columbia now passing over the Nile, and our INCO officer, Jay Connor, zooming in on the Nile as Columbia passes over. It's Mission Control Houston. We've now handed over for data reception to the Indian Ocean Station. We'll continue to take KU band television through the eastern satellite for about another 3.5 minutes. Columbia now passing out over the eastern coastline of Africa, the Horn of Africa, and the Indian Ocean.
Columbia Houston, we're 2.5 minutes from TDRS LOS. We'll see you on the west side at 1935.
Okay, see you there.
It's Mission Control Houston. That concludes some unscheduled television from Columbia as she passed out over Africa on this orbit. We're about to lose signal through the tracking and data relay satellite in a minute and a half.
Stars in the table. We have the data, and you are go for the alignment.
And as we near the end of this pass, the crew's been given a go to do a bit of celestial navigation. They're taking a pair of stars into the star table, and from there into their inertial navigation platform. This is Mission Control Houston. We've just concluded taking some unscheduled television from Columbia. We've now turned the satellite around and we're broadcasting again from Johnson Space Center with commentary and video live on the NASA Select network.
Houston, contact, any contact.
Columbia Houston, we're back with you through TDRS West. How do you read?
I'm clear.
And Marcia, if y'all haven't already done so, we'd like you to go ahead now and turn on the UHF.
It's on.
Columbia Houston, we send an orbiter state vector up to you. And also, your IMU alignment looked good, so you will not need to perform the alignment that was called out in the flight plan update at 2031.
Okay, we copy. Thanks, Dan.
Also, we have a flight note concerning the failed on RMS master alarm. It involves a short procedure, and let me know when you're ready to get around to working that procedure.
Okay, we'll give you a call. It'll be a couple minutes.
Yeah, understand, Dan. No hurry.
Houston, Columbia.
Go ahead, Columbia.
Yeah, Tammy, go ahead with the RMS procedure.
Okay, Bonnie. We are going to try and reset the failed on master alarm tone. And so what we'd like to do is power cycle the RMS DNC panel using the following steps. First, take the RMS power to off and then go to the PDRS checklist, page 1-2, and perform step 2, RMS temp mode.
Okay, Tammy, I copy that. RMS power to off and 1-2, step 2, RMS temp mode. And just a clarification on that master alarm. The noise that we heard did not sound like the master alarm. The master alarm is a series of tones of a certain pitch. What we heard was sort of a low-pitched tone coming continuously out of the speaker.
Okay, Bonnie, we copy.
And then it was intermittent. We haven't had it since.
Bonnie, we understand you to say that the tone is not on at this time. Is that correct?
That's affirmative. It was on for 2 short periods yesterday. It has not come back on. And it didn't have the same pitch or frequency as the master alarm.
Okay, Bonnie, we copy. Stand by 1. Columbia, Houston for Bonnie.
Go ahead.
Bonnie, based on your the new input, we're going to need to go off and rework this so you can do not perform the procedure we just read up to you, and we'll get back to you when we have something new.